Currently, I'm working at IBM Labs in Bangalore. So, I'm passionate about artificial intelligence and specifically the usage of artificial intelligence in the field of education technology. Moving forward. The abstract that I submitted for this conference was or college level students, basically freshman students in college, and this approach is based on feedback based tutoring system. So feedback is the most essential thing in the field of learning. A student learns with the help of a feedback. So we use that thing and inculcated it in the tutoring environment. So from the psychological standpoint, in this student learning, the most effective form of learning is known as self-regulated learning. So basically, self-regulated learning is a form of learning in which a student can set a set of goals that he or she needs to achieve in order to get done with a particular topic, and proceeding forward with these small sort of accomplishments, there's a sort of like a motivation, a learning motivation that I have completed these set of tasks, these many are left, and once I get done with all of these things, I can move on to the next thing. And that eventually leads to the productivity of the entire thing. So what are the effective teaching guidelines? Studies have indicated that immediate feedback method actively engages the learners into the discovery process, that where they are currently lying in the learning spectrum, how much they have to learn, how much is left. And it basically promotes the correction and retention of inaccurate response strategies. So basically, if I'm doing a certain set of problems and at particular step I'm stuck, I may take a step forward and might find out that I am correct or incorrect in certain way. So if I am correct, I would like to retain that information, and if I am not correct, I'll basically reject that and improvise myself to learn better and get better at it. So basically, immediate feedback suggests that as soon as something wrong occurs, you basically tell the student that this is wrong and you need to correct it. This is analogous to a child learning something. For example, if there's a child and there's food lying there on floor, he picks it up and starts to eat it. You, as a parent, you report it at that particular moment that this is wrong and this is right. You shouldn't do this. So as you keep on doing this 3 or 4 times, the child actually retains that information. And keeping that in mind, it starts like, if he or she is doing something wrong, then it suddenly comes to the mind, pops up to the mind that this is wrong and this shouldn't be done. So our motivation for making this tutor was like, the current tutors which exist are basically, if I'm stuck with a particular exercise, I'm done with that exercise and I'm wrong, the tutor restarts that exercise with the initial set of data points refreshed each time. So basically, I started with for example, I'm creating an AVL-Tree, there are a set of numbers and I need to insert in an AVL-Tree. So if something is wrong, it will tell me at the end of the problem that this was wrong. Current tutors do this, and basically it will restart the exercise with a set of new numbers. Second sort of tutors are using animations and visualizations to indicate, giving the visual cues to the students that this is the next step, you need to go in this direction and this direction, but that is way too trivial. The third is the problem set. So basically there are certain sets of problems which are allocated to students, that these are the set of problems that you need to do. And at each moment of that problem, if I'm stuck at one problem out of 5 problems, there is no way that the tutor tells me that you are wrong in this problem. You have to complete those 5 things. The results will come after that, and then you need to start with a new set of problems. So all of these strategies use an active feedback system. So why did we choose AVL-Trees? Basically, we conducted a survey in my institute, IIIT Jabalpur, and we were thinking like, what was the most complex course in the entire computer science thing that we did, computer science degree, and most of the students reported that it was data structures, and specifically in that 70% of students said that it was the concept of AVL-Trees. So personally, I think we should have done on something else, but AVL-Trees is fine. Basically, this is a very generic approach, so it could be applied to everything. So current implementations are too complex to understand. Basically, there are some sort of visualization tools that help the students to learn that this is how you should proceed with a particular problem. This is like stepwise approach, but those are too complex to understand. So technical aspects, how did we create this tutor? In order to facilitate the faster development of this thing, We use this open source tool known as cognitive tutor authoring tools that is developed by Carnegie Mellon University. So basically it facilitates the rapid development of any tutoring environment for students. So it basically has two components, the HTML web interface and state behavior. State behavior basically consists of a set of correct states in which a student, like if I'm correct, that particular state would be considered it analogous to the finite state machine. If a particular state is correct, that means I'm on the right position, then that state would be marked as a positive state, otherwise that would be a negative state. So leading to my input decisions that I inserted a correct number or wrong number, it will like lead to these set of states, and that control of that state behavioral flow would be controlled by the HTML web interface. So like, let me show you the demo. Yeah, so this is a very basic application that we have right here. So this is the web application. There are two steps to it. So first is a how-to, and this basically shows basic introductory sort of 5 minutes read that this should be done. These are the sort of rotations in AVL-trees. This is the prerequisite information in order to like kickstart with an exercise. And then in the end it shows that how insertion is actually done in the case of AVL-trees. Now moving on to the tutor part. So these are a few set of steps which are given that how to use this tutor, like given these are set of numbers, you need to insert them into these text boxes and all. So given the first number is 64, I would like to enter it over here. Yeah. So like this is highlighted in green color, that means I am at a positive state currently. Moving forward with the next number, I enter 1 over here. So yes, green again indicates that it's a positive state. Now, for example, if a student is now confused that where he should enter the number, so he can like click on the hint button and it will like indicate by red or orange color that you should enter a number over here. So as I move on to the next insertion, it basically tells me that now this is an unbalanced state. You need to balance the graph because the balance factor is going out of, yeah. So it will tell me that you need to do this and that. So basically this is a basic sort of prototype that how this application is going to look, and this is how it's going to proceed. So even I can like still ask for second level hints over here that number 44 is to be entered here in order to like facilitate me from learning how to actually perform the rotations. There are certain levels of like second order and third order hints also. So this is basically how the application looks, and once the entire graph is filled, the student can click on the done button and it will say that like you have completed with the exercise. So this is basically a 4 or 5 minute exercise for a student to do as a supplementary material before the actual exams occur. So let me show you the user study that we did. We actually wanted to see if this thing actually works or not. So for user study, we considered these two, we were having these two approaches in mind. One was the traditional learning approach that consists of a learning phase in 2 activities, that is regular classroom teaching and the textbook study that the student does it on his own. And the proposed learning that we are proposing is that the classroom teaching, textbook study, and the third step that we are introducing is that tutor part. That is basically a 5 to 10 minutes exercise depending on the topic. So the learning phase that you're proposing consists of 3 steps. For the evaluation, we had these mid-course exam and final exam. So we implemented this, like when we were doing a study, we had a classroom of 50 students. So we divided the classroom into 2 halves, and mid-course we evaluated just to see that if both the halves are on the equal platform or not. And more or less, it's differing by 1 point, but that's fine. Basically, we are considering both the halves to be at equal stage at a particular point. But after the second half was made to follow the tutoring thing that we made, and we could see the drastic differences of 10 points after we had the final exams. So these are the average scores out of 40 that we got. So like what's the scope for the future is, basically this application is very generic in nature. This isn't very specific to the AVL-trees that we are proposing, but this could be applied to each and every topic in the learning as well. So we aim to, the aim is to make this tutor more personalized to each student so that actually we can gather the data from the students that where they actually face problems, where they got the hints and all, and use that data and like basically put into some intelligent algorithm to find out that what is the basic problem the students are facing in the classrooms and give that feedback information to the teachers so that they can improvise changes in their courses. So thanks, and if you have any questions.
Thank you. Questions?
Question. I would like, if you have time, I would like to just take 2-3 minutes to see how that rotation gets handled. Will you be able to show that?
Oh yeah, sure.
We have that.
Okay. So basically, I'm on a step that is unbalanced, so it's asking me to perform a rotation over here. So yeah, for the first, I'll perform an RR rotation. Okay. And I'll remove this. Okay, and now it says that I need to perform an LL rotation after this because it was an LR rotation. So I'll put 64 over here. Yeah. So it again turns green. That means I'm on the positive state currently.
Will it do the rotation for you?
No, no, no. Then what would be the point of learning of a student? The student has to perform their LAN only.
It can't do it. Will it tell me how it gets done?
Yeah, it will tell me that fill this number over here, fill this number over here. It won't do it automatically, but it will ask the student that do this and do this. Yeah.
If the algorithm is displayed, it will be more meaningful.
On this page
yeah,
itself?
the algorithm, yeah.
Oh, okay. See, I'm open to suggestions and feedbacks here. Yeah.
Other comments? Yeah.
So the post-test that you mentioned, was that the test which was designed by you, or was that some kind of a final exam in the course itself?
No, no, no. So actually the study was conducted in 2 parts. So when I was in IIIT, we had this summer course running of 2 weeks on data structures. So after the end of first week, the mid-sem was conducted, and after the second week, the end-sem was conducted. So we conducted the study over here, and it was a regular, not a regular course, but a 2-week mid-course for the summer. Yeah. And
so the exams were not your exams; they were exams created by somebody else. Oh, very good.
Yeah.
So the related question to that is, so you're showing quite a substantial improvement in the score. So is it the case that many of the questions involve this particular skill?
Actually, see,
what would you attribute?
That's what I'm saying. The exam was not designed by me. Only the application.
No, it may not have been designed by you, but were many of the questions on that exam dealing with? Because so you know, this is, I think, something that, you know, we wanted to select this paper. We wanted to get it because we want to encourage this kind of research and then take it to, you know, higher levels. And I know you attended Sridhar's workshop yesterday, and I'm sure you have a lot of great ideas following that on how you can make this. But, you know, one of the things that he mentioned is, of course, now the question is, well, why does it work? You know, because you know, this is an important question, and you know, more relatedly, as you get involved, and I sincerely hope you will get involved in the research, because this is an interesting area, is, you know, how do you provide these hints in you know, what is the best way of providing the hints? Is it in this style? Are there subtler ways? Because this is literally telling you, do this, right? And as Dr. Natarajan said, you know, would it be helpful to show you where you are in the code as you are doing this, you know, because that's really helping you visualize. There are many more issues that can be explored, but we really wanted to, you know, as I said, from the set of 30-odd abstracts that we received, we did want to find the ones that were most promising, and thank you for presenting.
Thank you.
Thank you. So our next speaker is Neeraj Goyal from IIT Ropar. So I had a quick chat with Neeraj. I think he's presenting one of the many things that they're doing in IIT Ropar. And again, it's very interesting to see
for the mouse pointer
what's happening.
Hello, good morning everybody. Okay, so this talk is about how do we teach computer architecture at IIT Ropar, and more particularly how we set the lab assignment part or lab exercise part so that student can learn computer architecture. So So before we start, so essentially the goal of computer architecture course could be slightly varying. So for example, we had one presentation yesterday. So that was according to AICTE guidelines. That essentially has two courses, one digital design and computer architecture. We kept these two things separate. Digital design is separate and computer architecture is separate. The objective which we kept for us, by the end of the course, students should learn at least these four things. First, that they should understand how to write an assembly program. So let's say given a C program, how to convert, or given a problem, how to write an assembly program. And then the second part is how to design a processor. So the focus is on designing, not on the on learning a pre-existing architecture, but what are the design principles, how the processor would finally get designed in hardware. So the pipelining part will also come automatically, and how processor interface with the memory. Memory means cache, first level cache, second level cache, main memories, and also a virtual memory. And then how it interface with the outside world using input output or interrupts, exception, etc. And keeping all these four objectives, each of these four objectives, they have to understand what's the impact on the performance. So basically, how will I design, for example, a processor so that my performance is good? How can I write a program so that my performance is good? And what is the impact of memory hierarchy on the performance? So keeping these objectives in our mind, we explored what are the various options student can use so that they will do hands-on, they will be able to do experiments so that they will be able to learn all these things, probably by doing. Okay, so various options which are there. One is using some kind of architecture tool. Okay, so there are various architecture tools. Yesterday also we have got a glimpse that there are too many architecture tools which are available. So, but most of these architecture tools, what they do is that you fed in your program, and after that they will be able to tell that if for one configuration this would be the performance, for the other configuration this would be the performance. So essentially you have to interpret the results. It doesn't give you insight directly. The other, and there are tools for specifically for memory, there's tools specifically for the processor, for caches, for DRAM. So all these tools give only one particular point result. So for example, the tool which has been created so that people can write assembly programs, so they will be only able to learn assembly. And processor design, mostly performance part of the processor design would be covered by these simulators. For memory and cache, you have to use separate simulator. And so one other option is that you modify these existing simulators. If you modify these existing simulators, there are a lot of challenges, issues. For example, these simulators are huge. It's even difficult for PhD students to modify, forget about masters and UG students. But if you modify, then you will be able to understand what are the insights of the processors. The other approach, which is also used by some of the people, mostly in electronics background, that you model the processor in RTL, register transfer level. That means you will design all the component very accurate gate level. So then you will understand, yes, how processor is designed. But that's the only part. You will not get to have information or basically understanding of performance, IO, memory, or assembly language. So what we propose is let student design a simulator, processor simulator by scratch and on their own. Okay, so this particular idea will also let them understand how actually assembly work. So you write an assembly program, how does it work on that simulator? And because they're writing a simulator, they're writing each and every component, they're modeling each and every wire and signal, so they would be able to understand processor design also. The rest of this part depends on what all they are able to do extra. So for example, if they are able to integrate memory, they will be able to understand memory. If they are able to integrate interrupt IO system, then they will be able to do this. Performance is the another thing which we have to design assignments in such a way that they would be able to have some insight on the performance. Okay, so looks good, but the major challenge is the students for this course are mostly second year students, maybe third semester or fourth semester. So these students have no idea how to write a big simulator, and they have no idea what simulator is. So this when you say that you have to design a simulator, you have to implement a simulator, that task itself is very daunting for them, and they will probably step back and they'll say that they'll not be able to do it, they'll not be doing it. So to circumvent these two things, what we suggest, what we did, or what did is two things. One, I gave them the design document, basically all the functions they have to write, how they will interconnect with each other, what are their interfaces, and along with the design document, which is a detailed one, the other one which I did is I also write a very basic template of the code. So essentially what finally they have to do is they have to fill in some section of the code. And interestingly, this basic code was around less than 100 lines of code, but giving them basic 100 lines of code so that they can prepare their 500 to 1000 lines of code was very helpful, because now they know how to start. This starting is the major stumbling block where they struggle. Okay, so for reference I have put that code here as a GitHub. So otherwise I was sending them as a zip file, but I thought it would be good that if somebody else can use it. Okay, so let me go through the overall design of the simulator. So basically the overall flow is something like they will write an assembly program, probably in a text file, and that assembly level program would be converted into binary code. But this binary code is not 0101, but it is ASCII in the sense that so that it's readable. Okay, so this processor simulator will take this ASCII code, will load the memories as the processor do, and after that it will execute instructions one by one, and for each instruction it will give output. It will say that this is the result of this instruction, this is how fetch happened, then this is how decode happens, and all those things. And finally it will also modify the memory so that if there is any change in the memory, we can see afterwards whether the program was successful or not. Okay, so this is how my memory file looks like. So for example, this is the address PC. On this address this particular instruction is stored, and on this address this instruction is stored. So this way they will also get an insight that the processor reads these numbers, not the mnemonics which are written over here. Okay, and by the end of the course, by end of this designing the simulator, they are very comfortable understanding what this code means, because they are doing a lot of debugging. Okay, yes.
So the ISA is your own ISA or substantial ISA?
Yeah, I'll tell in last couple of slides. So we have experimented with all 2-3 different kind of ISAs. Okay, so this is how we suggest them to write their output messages, that let's say for each instruction all these 5 modules they have to implement, and instruction fetch, that what is the PC, what particular instruction they have read, and in decode what all operations they have done, operand 1, operand 2 they have calculated. So they'll write all these things in a verbose manner. Writing verbose helps us in evaluation, also for them in debugging that how things happen, also probably will help them in understanding things. Okay, so now I'll go through their 4-5 possibilities. This is the basic vanilla version that they have to implement this simulator, where the red means that these are the function blocks which they have to implement, and these white means they are essentially wires. So the goal there which is given to them, that whatever is taught in the classroom, if we are saying that there is a signal, there is a signal that will connect fetch to decode or decode to execute, then they have to model that as a variable, so that the correspondence is one to one. If anything that happens in hardware that is executed in hardware, that should be part of these function units or these stages. Okay, so initially when we get we'll get this memory file. So this memory file, let's say we define it as a loader. So this loader would push all these values in the memory. This memory is an array, is a byte addressable array. So if there are 4 words in one instruction, all those would be stored at 0, 1, 0 cross 1, 0 cross 2, 0 cross 3, all those addresses. And initialization of PC would be done at whatever default address is, let's say 0 cross 0. And then a register file will also be initialized, because we have to initialize stack pointer at certain place. So otherwise, yeah, after this initialization phase, then all the instruction will get executed one by one. So for example, PC fetch will read from the PC, it will send the instruction, it will issue a read from the memory, and then whatever is the result, it would store it in instruction word, and instruction word will get decoded. Okay, so to make things easier, so we kept all of these things as a global variable or a static variable, so that all these functions does not take any argument. Whatever is there in this design, it is all accessible for them. Okay, so this is how the simple functional simulator will work. It's fairly, I would not say very difficult, but depending on the instruction set, probably it's 400 to 500 lines of code. Okay, so because here in decode you have to write every condition that when the instruction will get executed, which instruction will get executed, and execution happens based on only on those control signals. Okay, so if they are able to finish this functional simulator part, then the next step is that they have to implement so they have to implement a pipeline 1. In pipeline 1, PC is not the only register, there are registers after every stage. Okay, and the way I suggest them to implement register, that it should keep both the values, older value and new value, and whenever clock happens, whenever there is a clock tick or a new iteration of the loop, the older value should go to the new value should become the older value, and we should always read from the older value. Okay, so this is how all these registers would be implemented, and we suggest them, or this is the end goal, that whenever they will finally able to do this functional simulator, it should be one binary, not 2 different binaries. So that means the same design. Whatever they have designed in their previous function simulator, that should work as is here also. The only addition is they have to introduce these registers. And if you say pipeline is off, then it should work like a simple function simulator. That means in one cycle there would be one instruction would be finishing. Okay, so once they are able to do simple pipeline using stalls. Stalls means whenever there is a dependency, control dependency or data dependency, they have to introduce a bubble. Okay, so once this thing is achieved, then we also give the other part here, that you also make 2 versions of this pipeline, one without forwarding and with forwarding. Without forwarding means that they would introduce all these bubbles, and with forwarding, that they will be able to read from the next instructions also whenever decode happens or execute happens. Okay, so this was kind of fairly challenging, because they were struggling onto multiple issues. They don't know how to stop this, how to stop the simulator. So for stopping, we suggested that let's introduce one more instruction which was not there in the original ISA, called halt. So whenever this halt will happen, then we'll say that we'll stop. Okay, the other thing is finding these dependencies, which is finding these dependencies, because this instruction has gone further. So that was little tricky. Students came up with their own solutions, yeah, which was fairly good in the sense that all the state-of-the-art simulator, they use actually those methods only. Okay, so after these 2 basic things, then they would we believe that they understand more about the processor design aspects and pipelining. And then all the rest of the things are essentially extensions. Extensions means that once the processor here, processor is reading from the memory unit, reading from the memory unit, so memory database, and now here to increase the performance, I can say that this memory access essentially take 4 cycles or 5 cycles, so that means we have to introduce a cache here. If we have to introduce a cache, then we have to model the cache also. So that means we have to find out, given an address, how to find whether that address is there in the cache or not, so that they have to segregate tags and addresses. They have to say that if it is more than one way associative, two way associative, or 4 way associative, which one, which particular element to be replaced, so which replacement policy they have to keep, and how to maintain dirty bits. So the whole idea here is also that once the design is given to them, so once we tell them this is how you have to instantiate a cache, what data structure they have to use. So this designing a cache controller is also probably become 200 to 300 lines of code, basic one, not the extensive one. Okay, so if this framework is ready, then there are a lot of options. Lot of options means we can ask students to design their own assembler. Instead of using ours in assembler, they can also add their own custom instruction other than the which are given by ISA, and they can have little more complicated cases like this instruction requires not 2 register file reads but more than 2 register file reads, etc., etc. Multiple issue processor, a simple one, a kind of a VLW processor, where you say that if there are 2 instructions which are consecutive, they are independent, they can be executed in parallel. So that kind of things can be easily extended using this. Multiprocessor means that they have to now instantiate, so 2 objects of this processor, so that both of them will start essentially from the same address, but there would be additional instructions which will say that if the processor ID is this, then it will jump to that particular address. So the way usual multiprocessor works. So adding only 2 or 3 instructions, they would be able to execute multiprocessor instructions also. So when they're doing such kind of program, they have to do all these things. They have to add those additional instructions, they have to modify the simulator, also they have to write test programs so that they can see whether it is working or not. Okay, so integrating interrupts and exceptions and branch prediction. So this list can go on to whatever level, because we are ready with the basic framework, so extensions are only the limited by the imaginations. Okay, so this is about how how student fared, or basically what kind of architectures we use. So this particular approach we have used in 4 different sessions. 2014-15, the students were from the second year. Class size was also large, around 180 students, and it was not an IIT. So I'm stressing on this because during discussion in last 2 days, people are saying that okay, for IIT students you can give more complex problem, but that's why I'm saying it's not an IIT, and the class size was also large. The architecture set I took ARM because the class size was large, and also I was also teaching first time. So we were able to implement only the functional simulator, not the pipeline one. Students were able to implement functional simulator. It took probably 6 weeks of time. And then next time, so this is 3rd year CSE students. Here students were CSE as well as electronics background. In CSE students, the class size was around 40, and we took a simple RISC as the base architecture. Simple RISC is proposed by Smruti Sarangi's computer organization book. And yeah, so in that case, they were able to implement functional as well as pipeline simulator in around the same 6 weeks time. So after midterm they started, and by the end term they were able to finish. Then I said that let's take this as a base case. Base case means whatever best a student have able to implement that in the previous year, they took that particular code, and I divide them into multiple groups. So some group have implemented multiprocessor, some have integrated interrupts exceptions, some have done VLW processor, some have integrated SIMD coprocessor. SIMD means like which can take one instruction but can execute multiple operations. Okay, so The next year my colleague taught it, and the semester, because of curriculum change, the semester was 4 semesters, CSE students, and the architecture we took was risk-free architecture. So here he was able, like his students were able to do almost all these things, implemented assemblers. So he first asked them to implement an assembler. For all these 3 cases, I gave them assembler. Functional simulator, pipeline simulator, also they were able to integrate cache. So one more thing which has to be pointed out here, that along with these projects, first half of the semester was spent only in writing assembly codes, so that they understand how to write assembly code. Then this part is essentially how processor execute those assembly code and what are the impact on the performance, etc. Okay, so with this I am almost done. So essentially what we observe, there is no study done per se that what is the increment or enhancement in their understanding. Yes, but students were delighted when they finished this project, and they proudly write all those things in their CV that yes, they were able to design the whole simulator. Okay, so the other thing which is observed, that if we give very clear instructions, if we give more details of the design, if we clear all the doubt early on, then they are able to finish better and early, because the kids are only from the second year. As they grow from third year or fourth year, then we can also let them do on their own, but in the second year the things are, yeah. That's it.
So now I know where I want to go back as a student. It's really great.
Professor, it was a very interesting talk. A couple of questions. The implementation of a, what you call now, pipeline, architecture simulator, that's great. But how did these students test this architecture? Because it has to be tried with permutations and combination of, instructions, branches, and various things, So have they done a very thorough, strategy for,
Okay, so in first half of the semester, they have already developed many programs. So for example, they know how to do Fibonacci, they know how to do factorial, and how to handle memory, so for example, memory multiplication, etc. So we ask them to use these test cases, these codes as a test case, and because of assembler, you will have the binary file for all of them, and because of that, you can feed that. You can feed all that in this system, and with these results, you will be able to say whether they are performing correct or not. Correctness is not an issue. And performance of the simulator itself, we don't care. Like how fast their simulator is, we don't care about that. But correctness, we are able to check, because we say that at least these algorithms should run. So for example, they should be able to handle memory, so memory multiplication should work, and also Fibonacci as a simple case.
No, according to me, operating systems and theory of computation are the 2 core papers which students acquire knowledge of to design such kind of architecture or such kind of assembler.
I would, yes, I agree and disagree. So basically, the computer architecture course, the prerequisite of computer architecture course is only and only basic electronics or sometime digital design. That's it. Okay.
So how are they working with the clock and pipelining concept?
Pipelining we teach. Pipeline we teach, and your question is correct that without understanding operating system, so there is no operating system involved here. So they are taking one instruction, 0 cross 0, this is the PC, and after that PC the instructions will get executed in all these stages one by one. So it would be fetched, so for example, so it would be fetched, and after that whatever instruction word they'll get, they'll decode it, and after that they will decipher all the operands.
They will use the switch case kind. They will use the switch case statement kind of thing.
Yes,
like,
yes,
okay.
yes.
And one thing was like how they differentiated between memory and cache memory, means like main memory and cache memory.
So the simple design will use memory, and memory is essentially an array. So for example, I say my memory can have 1000 words, so that means it would be 4096 size array. So whatever my address is, that address will go to PC, and there would be a small API which will say that using that PC, next 4 consecutive bytes you read and give it as a word.
All the cache memory will be faster than memory.
We have to say, So basically when they are designing cache, then we say that whenever they are accessing memory, it will take 10 cycles. So this concept of time has to be introduced, latency has to be introduced. Yes.
Sir, I have 3 questions because usually.
In the interest of time, can we restrict to one? Because
Yeah, he can tell the answer in one sentence also. Do you have separate lab for this course, or do you have integrated lab for this?
Integrated.
Okay.
Integrated, but yes, 2 hours separate. Time
Because it needs so much time for the students to implement it. That
2
too in
hours of
second.
lab. 2 hours of lab per
Okay.
week.
Okay.
So, but one thing, what luxury we have, so we don't expect them to finish in 2 hours. We simply gave them after
Self-learning
midterm,
kind
and they say that you can do it on their laptop and in their leisure time whenever they can finish.
So, did you assess this implementation and included in their continuous internal evaluation?
Yes,
Okay.
substantially.
So did they do
one
it?
more thing which I forget to say, it's C, C++ implementation, not any other language. So not Python or Java or whatever.
Did they do it in group or individual?
This one was done in groups of 2.
Okay. Thank you, sir.
Thank you. Yeah.
So, is your program, is the system organized such that one group of students could be designing the memory and building it, testing it, somebody else's designs?
See,
Can you design in parallel?
yes. So let's see. So if people are doing it using Verilog, that's the approach they have to take. There is no other option, because Verilog design is big. But here, because it's a C, C++ design, memory means it's an array. Done. It's an array of, for example, if I say 1000 word memory, so it's a simple array of 4.
No, but your cache is a complicated logic. So I might say that, look, I want to design, this group designs the entire cache subsystem. This group designs the processor, and now the interface has been defined so that if I put these two together, it will work.
So the way course also went, so first you have to you teach processor, and after that caches would be taught. So caches is kind of an independent module in itself. So they can also design independent cache rather than whole integrating cache with the processor is interesting, but it can be done as independent thing also.
Okay. So and this diagram that you have drawn, do you have visualization tools? I mean, is there a graphic? Can I see the current state of my processor, whatever I have designed? Can I see it nicely, or they have to put in explicit print statements or something? Explicit prints.
Because it's all C, C++ design, so the way some kids have done, that's very nice. So they have written it in a textual manner, each stage of the pipeline also, and but it's up to them. Otherwise, I simply say that you write verbose message and try to interpret from them, because it's their own code, so they understand it well.
Maybe you should integrate it with your system. It's a great thing, great idea. I know where you're going with this. Okay, let's thank the speaker once again for a great talk. Thank you. Meenakshi? So the third speaker in this session is Meenakshi Lakshmanan from the Meenakshi College for Women in Chennai. And she's going to be speaking about an academic progress monitoring system.
Yeah, I've loaded it.
You have put it on
I
desktop?
put it here, yeah.
Yeah, and it will be in this thing.
Okay. I got it. Okay, yes, yeah. One second. Namaste, everybody. Namaste, everybody. Good morning.
What I'm going to present today is an academic progress monitoring system that's about, that deals with assessment portion of what we do. I'm Meenakshi Lakshmanan, as Viraj sir just said. I did my post-graduation in MCA. I'm not an engineer. And after that, I went to the software industry, but then I came back to what I felt was my calling in life, which is teaching. My colleague Suganya, who's my student turned colleague, couldn't make it, so I alone am here. What we do with usual academic progress monitoring is, okay, we design the curriculum beforehand. I'm talking about when we have autonomy. Then we deliver the content, which is our job. And then we do student assessment. Actually, this is not a very accurate thing because after student assessment, we don't exactly design the curriculum, but maybe we make some curricular changes in case it's required. Curricular changes, pedagogy changes, whatever. Now our problem starts when we finish the assessment. So when the results come, that is when the semester results come, what comes? We just have marks, grades for the whole list of students. We have a result sheet. And we have marks, grades, or pass-fail for all students. So we get the pass percentage. Okay, sorry. So we get the pass percentage. So the student has failed. Supposing she has failed, she's part of the the failed category. This is all we see. What we don't see is that probably in the past few semesters she has done well, perhaps. So what we don't see is that the same child had got, or the same kid had got A+ earlier. So this is something we don't know when we see that one sheet of paper. So who passed, who failed, we have the pass percentage. Basically, it's a whole lot of numbers. We had, I think Saurav, I think his name was Saurav, he spoke about how he had a automated system where they have tests, and then they're able to tell us which question was done. I mean, how many people passed, did well in one question. 20% did badly in this question. 40% did badly in the question. They're all numbers. Now, if the percentage is somewhat same as last time, we look at the pass percentage, we say, okay, 90% have passed, then we can go to Moody Cave, meditate in peace. If it's better, then of course, we can go on that cruise. If it's worse, then the normal reaction is that the students are all Dennis. Oh, they're not serious, they're too playful, they're too distracted, or whatever. I mean, what else can we do? All we have is the numbers of that semester. We don't have data. So we can't really blame ourselves for this kind of analysis. So, I mean, that's what I just said this. So we don't know if the student is at fault, or the student needs help, or the curriculum is bad, or the teaching is terribly wrong. We don't know with that one sheet of paper. So our solution is that we bring in a historical perspective, and we also bring in the socio-economic perspective to the results. Okay, so what we've done is a very basic tool that facilitates this kind of extraction of historical information, socio-economic information for every student. And we've designed an academic progress monitoring system, which is called APROMS. It's just a simple web application with which we can track every student. So we don't look at the numbers, we look at the people behind those numbers. Okay, these are details. The point is it generates graphical reports which we can read very easily. So I just show those to you. We also have a quality control mechanism. I happen to be head of the IQAC, and therefore there was that quality thinking as well. Fortunately, I'm no longer in IQAC, so thank God for that. Okay, so now the criteria that we put into this data analysis for this APROMS was we look into whether a student is from a socially disadvantaged background, economically disadvantaged, is a first generation learner. In fact, in our college, a lot of them, about 70 to 80% of students are first generation learners. In 2019, it's like that. Sorry? Their parents are not graduates. These are the first generation which is actually coming into graduation. Yeah, in 2019, the country is still like this, and I'm from the metropolitan city of Chennai. So you can understand how it is out there. Physically challenged and needs academic support for some reason or the other. So these are the criteria we took into account. And we have 3 parts to this: continuous performance tracking system, arrear tracking, and a small remedial coaching system which is very targeted. So let's just quickly get into, before Viraj sir can start raising his hand, we'll just quickly get into these. I'll just jump into it right away. What we do is the system just generates reports in Excel. So it's easy to manipulate. I mean, easy to handle, we don't manipulate them. Sorry about this, the quality of this, we've just taken snapshots from bound reports. So what happens is, for example, let's just look at this report. This is a report for BSc Computer Science batch 2015 to 18. And this is for part 3, what we call part 3, which is core and allied, that is main and allied, which is a core, because we have English, we have language, all that is part 1, part 2. Now, I'll just quickly go through the various aspects of this. There's a graphical output. Incremental progress is tracked. That is, we have the x-axis is a semester. So we have the first and the second semester. So the students are in the second semester right now. So we have, when she's in the second semester, we show a graph for all the semesters, first and second. Class average is also mapped. You see the dotted line, class average. Please remember this is not subject wise, this is for a whole lot of subjects. The average of all these students taken all over for all subjects. Each of these lines is a student, and the register number is here. The point is that, I mean, how do you really track this? It's difficult to do it when you have a printout, but when you have it in Excel, if you're just going to click one particular line, you're going to go to the data of that student. So it's easy to track. Yeah, so this is community-wise. We generate these reports community-wise. In Tamil Nadu, we don't have just OBC and SC. We have BC, we have FC, we have BC, we have MBC, most backward, and then we have SC, ST. So we deal with all these separately. So this is, for example, MBC student progression. So they are from a socially disadvantaged background. And so we want to look at how they perform. Of course, this report is telling us that the students are already in the first semester, they're already up here. So this really shows us that what I've always believed in, that the students do badly because of us, and they do well not because of us, but in spite of us. So us in the sense of teachers. So this gives us an inkling. Suppose we have something dipping here, then we've got to wake up. There is a quality control flow, which was all that I was thinking of at that time. So you have people vetting it, so it has to go through a process. Socially disadvantaged, we track that. Now look at this. We have now the same set of students who've come into the 4th semester. So you have all the 4 semesters mapped. So we had a dip. If you saw the graph went downwards in the 2nd semester, but then we've remedied something apparently, or they've remedied it themselves. They've gone up. So this is very satisfying when you see reports like this. Okay, and this is 6 semesters. So all 6 semesters, how gently they've gone, where is a class average, where do they stand? So a lot of these students are performing much above the class average. So we see a dip in the last semester because their placements come in. So they're a little busy with that. Okay, the second thing which is which we've found a lot of success in is the arrear tracking system. Now this, what we do is we generate these, reports are auto-generated at the end of every examination, that is whether it's regular or supplementary. So in our college we have a regular exam followed by the supplementary exam. We don't have arrear papers taken along with the regular exam as is done in universities, simply because the thinking is that the student is not able to clear a paper, you ask them to clear one paper along with 5 others. So it's not possible to do that. So what happens is, for every class, this report is generated, where here you find list of students who have not passed, so who have failed this semester. 48 students have appeared. I'm sorry about this bad scanning of a report, of bound report. So the pass percentage is 83.33, but we also want to know who has passed. So this is a list of students, register numbers, who has failed. So they've failed here in what subjects? There could be more than one subject. Now here we have data about whether they're economically disadvantaged. I don't know if you can see this at the back. Whether they're first generation learners, whether they're physically challenged. So we have that information provided here. This could be an indication. I'm not saying that if they're first generation learners, they are going to do badly. No, not at all. They could be more motivated than the others, in fact. But that could be an indication that maybe they don't get support at home or understanding at home, whatever. So the next is just turning the whole thing around. This is subject-wise and how many students have failed. You see in this subject, there are 8 students who have failed. And this is a programming language paper. 8 students have failed. So what we do is, we sit down with the students and we talk to them, the teacher who taught plus the HOD. We sit down with the students and we ask them what went wrong. It could have been that the student was not well on the day of the examination. It could be as simple as that. That's not something we can do anything about. So then she just writes the supplement. But there could be more, more specific problems. For example, that they didn't practice programming well enough. They were able to write smaller tests because maybe they just mugged something and wrote, but they didn't really get the programming right. So they weren't, and there were a lot of programming questions in the question paper which we don't have, it's externally set. So we find that out, for example, here, and then we have to plan a remedial measure and commit to that. So the teacher commits to that, saying that after college hours, we'll sit with them, we'll take them to the lab and we'll actually get them to do the programming and bridge that gap. So once this is done and it's all this quality process stuff is here, what happens? Okay, so I just explained that. In the supplementary exam, we find that, I mean, this is one of the success stories. We find that 8 of them have taken the exam and there's 100%. So we happily wrote, this is remarks on the implementation of remedial measures planned earlier. So we happily wrote that it was effective. Now, some cases are not as simple as this. This is just an example of how they could be multiple subjects. So the multiple subjects are here, and how many students failed in each of these, and what are the reasons. And we sit with them, and then we commit to what we're going to do, and then we do it. And all of them have passed. So success stories. Some of them are not success stories. In fact, sometimes we come across cases where what we did was why is all this relevant to curriculum and pedagogy? There was one case quite recently where this girl failed the exam. So we sat down and we asked her what is the problem. We didn't know about her background. There was economic disadvantage, all that was there, first generation learner. We found that she has a very, very troubled background. What happens is her mother was a flower vendor, her father a drunkard. And this girl had a little brother who was in school. Now, her mother goes for work, does odd jobs in the morning, evening she goes to sell flowers. The father's, of course, of no use. He just comes home to get money from the mother and beats her up. This is the situation at home. So this girl, but what we were doing was, we were telling them, we were giving them work to do at home. We were telling them, learn this up and come, so that next day, like what everybody was talking about, you do at home, we coolly go to class and just do discussions and we just do guidance. So we tried this, this pedagogy. We told them, you read all this up and come. This girl, she has to get up early in the morning. She has to cook. Her mother goes away very early, 6 o'clock or 5 o'clock she's off. This girl gets up, cooks, gets her little brother ready, sends him to school, does all the housework, rushes to college, goes back after college. She takes some tuition for some people around her place to earn that little bit extra. Then she cooks in the evening, cleans, washes clothes, everything. Her little brother comes back, she teaches him helps him for his schoolwork. The mother comes back very late at night. So where does she take work home and see videos and all this kind of high funda stuff? She can't do that. We didn't realize that. And we felt it was a failure on our part to not know that there is a child like this sitting in the class. We knew that when we actually tracked the arrear and why did she fail. And believe me, these students who are sincere, it really hurts their self-esteem to tell us these things. We really have to coax them to tell us that they have these problems at home. They don't want to reveal it. So we got her to actually come out with it. And then we realized that to hell with all this pedagogy of telling them to read stuff at home. Whatever they do, they do. I mean, for that particular class, that is. Because there was one student like this who can't take stuff home. So we gave them time to, do stuff at home. In the class, whatever they had to do, whatever she has to study in college. There's just no other way. So we made time for that. We adjusted the timetable and we did all that. We paid more attention to that class, and because we didn't want to, make her feel that she's getting special attention, and that really helped, hurt her self-esteem, because she was not she was a bright person. She was not a dull student or anything like that. She was not a slow learner. So these are the kind of problems that are there when you look at students, not just as percentages and numbers, but when you look at them as people. In fact, a few years back, just to share an experience, we came across a student who was regularly performing badly. It is not one of those success stories. So we had, even in the supplementary, she was failing. You give her support, seems like she's understanding, again she fails the next supplementary. Then we went deeper, because she seemed to be attending the class, she seems to be writing whatever we were asking her to write. But then finally we suspected that there's some psychological problem, and then we finally kind of understood there's probably approaching schizophrenia. She had a psychological problem, so we had to take her to a psychiatrist and get that treated. So there are students out there who need special attention. In fact, there was another case where a student had lost her mother. Her father had got another woman into the house, so she brought her brother out, and she was staying in a hut, and she was doing a PG here. She insisted on coming to college and finishing her PG. She said, I have to support my brother's education. So I'm going to do my PG and I'm going to get a job. And most of these kids, once they start earning, after they finish their MCA or BSc, they start earning, they become a major breadwinner for their families. So this process has really helped us do that. So at the end of the day, as teachers, it's been extremely satisfying for us that we're able to help even one student. Then we have this remedial coaching system where we identify, just finishing up last part, where we have students, we train them in English and mathematics if they need extra help, and then we track them. So this is after college. Sometimes we put them into peer groups. Same with pedagogy with the other two systems. We could put them into peer groups and get the training done. Okay, I'm extremely sorry for this awful looking graph, but there were a lot of students in this. The point is, if it's in Excel, you can really track it. You can really just click and go on to the... We also have a student feedback system for this teaching and curriculum. This is an extra thing outside this APROMS, where we have at the end of every semester, we have this, we just do this with Google Forms. So this also helps us with pedagogy and curriculum changes. So I've already talked about this, I'll just skip this. So overall this, and we have student feedback, and this helps us do curricular and pedagogical improvements at a different level. I mean, tier 1 institutions, probably it's a very different ball game altogether. But for us, it's different, and it's very, very satisfying to see all these students getting into the top software companies and making a big difference. So, thank you.
One question.
Sorry.
It's a wonderful presentation, ma'am.
Thank you.
And the efforts you are taking beyond, whatever, an extra mile that you are traveling. I appreciate that.
Thank you.
Ma'am, I just want to ask, it's a technical question. You told that you considered that socio-economic parameters also. I just want to know, it's a simple question, that have you considered the parameter of that primary education, like board they studied, in which they studied, and the medium of language? Like they have different boards, right? State board, CBSE, ICE, international, whatever, and the medium of language. Because
Yes, board of study, most of the students who come to us come from Tamil Nadu State Board. Some of them come from CBSE and ICSE, which those students are frankly much better equipped. No, we haven't.
Don't you think that also will help to understand the performance of the student? Do they have any dependency from the board which they have?
Yes, there is a dependency. I'll take that suggestion. We should include it. Yeah. The point is 99% are state board for us, so we really didn't get into that for that. And as far as a medium of instruction, medium of instruction, we admit only English medium students, but they're not able to communicate. That's why we have the remedial coaching for English and maths. So they go through that. They go through a peer coaching system, which is overseen by staff, by the English department staff. And after that, we've seen improvement in that. You saw the terrible graph, no? It was going up.
So I will just pause it here. Let's carry on the conversation offline. Let's once again thank Meenakshi, and I'd like to invite all the speakers for this session up to the stage for a quick handing over of our tokens of gratitude. Thank you so much. Arpit, thank you. Thank you. Neeraj, thank you. And Meenakshi, thank you so much. Thank you. All right, so we'll break for tea. It's 10:40. Let's try and be back as soon as possible. Oh, announcement. There's some announcements also.
A few announcements. We have arranged for a bus to drop the guests to the airport. It will leave at 3:45 p.m. sharp from the entrance near the Laran lawn. All those who have departures after 6 p.m. are requested to kindly board the bus before 3:45 p.m. All the participants will be receiving their certificates in a soft copy form through email. The third announcement is the travel grant recipients will receive the instructions about their reimbursement procedure through email. Thank you.
Now, a session on this industry panel discussion on the industry expectations from employees. And I will invite Hemant Pandey, who is a Chief Executive Officer at ACM India. He will introduce the panel. So let me introduce you Hemant Pandey. He has taken over as Chief Executive Officer for the last 1.5 years. And before that, he did his BTech from IIT Bombay and a PhD from Rutgers. He has 30 years experience in the industry. With that brief background, I will invite Hemant to introduce the panel and the moderator.
Thanks, Vivek. So, over the last 2.25 days, we have seen, we have learned various learning techniques, pedagogies, educational technologies, and so on. The biggest consumer of that, the outcomes which are in knowledge, in competency, skills, so the biggest consumer of those outcomes is industry. So what we thought is that let's hear directly from industry representatives. And we have a very good sample across industry today. So thanks, Vivek, for introducing me. What we are going to do is we are going to use a programming language construct for introductions. So Vivek introduces me. It's called multi-level pointers. So pointer to pointer to pointer. So Vivike introduced me, thank you. I'm going to introduce Venki, and Venki will introduce rest of the panel. So let me introduce Venki, R. Venkatesh, who's a very good friend and ex-colleague for 30 years now. So he's chief scientist at TCS Research. Also the outgoing chair of SIG CSC of ACM India, which is a SIG for computer science education, and the chair for education committee of ACM India. So very active in ACM. So that's our Venki. And then I'm going to hand over, oh, but you have yours already. I'll hold on to this so that I move around later. Yeah, so let's test it out. And over to Venki.
Yeah, thanks Hemant. Thanks for the introduction, and also thanks for arranging the panelists today. And he's managed to collect a good variety in terms of industry representations and also roles, as you might see. So I would like to first invite Mona Bharadwaj, who heads university relationships at IBM. And so that's one kind of industry and role. Then I would like to invite Pandurang Kamath from Persistent, who's associate CTO at Persistent and works out of Goa. And so that's the. Then third is Milind Anvekar, VP Open Destinations Infotech, again based out of Goa. And he also is a VP of Goa Technology Association. So that's, again, a very different role, heading a Goa Technology Association. So he represents a lot of industry in Goa. And then finally, I would like to invite Karthik Shivakumar, who is a principal engineer at Cisco Systems. Yeah. So, so we have all of them, and I'm just going to be asking questions. And at the end, I'll throw it open for questions from the audience. See where it goes. So it's going to be more a question-answer format where I just asking them questions and ask them for their responses. So you have your mic. Yeah. So I would like to start with, there is always a confusion between academia and the industry on the expectations, what industry expects and what academia thinks that they would win. And there have been various reports from NASSCOM, ASCED, various other which says students are unemployable or whatever. At the same time, the world looks to India for talent. So there is a sort of conflicting message there. So I would like to ask you all as to, do you see the students that you take are meeting expectations that you have from a fresh graduate? You obviously don't expect them, but having whatever you expect freshers to have. Yeah, I'll start with Karthik.
Thanks. Is this recording? Is the button on? All right, thank you. So I've done quite a few hiring from colleges. I've also had a chat with professors from a few colleges in Bangalore as well as outside. And usually I'm the first person who meets the new hires from college and scares them about the industry life. But the most important thing that at least we've noticed is, and it's not something wrong. It's just that I think something that needs correction is there's always a need to follow what the trend is. And today it's machine learning or the incorrectly named artificial intelligence. But basically, there's always this thing about chasing that trend. Unfortunately, what that means is that we started to notice a lack of foundation in the students that we hire. So we ask them very basic stuff, explain or draw me a hash table and tell me how this works. And they say, oh, I just import a hash table in Python. Or I import a hash table in Java and I have no idea how it works, right? That's very good for the basic programming that you do. But if you had to build something on the scale of what Cisco does, for instance, or if you look at Uber or any of these guys that have built massive scale, Google, who've built massive scale software, you need to know how to analyze performance of the software that you're building. You need to know what is it that actually changes the performance. So we think about concurrency and everybody says, oh, just launch a new thread and use a mutex. But that's not how it works. I mean, you launch a new thread, there's only 4 cores on your PC, for instance, right? If you run 30 threads, that's not really going to help your performance in any way. But that's completely missing. Those kinds of foundations are totally missing, right? Everything is made into a simple soundbite in some sense, right? It's basically launch a thread, run mutex. Handling concurrency with mutexes is so hard. It's the same thing with a lot of the other areas that we look at. I think that foundation, if that is there, everything else, as the industry changes, you can learn and you can go up. Machine learning, to be very honest, machine learning is basically statistical analysis from, 30, 40 years ago, right? And but done in a very nicely automated way that makes it easier for everybody to use today. But the thing is, when I was in college, there was neural networks and nobody took that class, right? So it's considered very boring, and I wish I had taken it, because today that seems to be the in thing. So the industry changes, right? But the foundations do not change. How do you calculate performance? How do you manage basic software engineering principles? They don't really change as much. I think if we build that foundation in, everything else after that will have to be learned, because things keep changing. And they will be learnt. So that's what we see, at least. So.
Sure. Yeah. So my whole theme kind of today that you'll hear through the entire event is, I think, the ability to excel in industry, or some of the students may go to academia. A lot of that has to be innate in the world we live in and the future we are heading to. So I firmly believe in 3 things, right? So I think the academia, or even later the industry, should be enabling, teach a student how to fish rather than, train them into catching certain types of fish only, or eating fish and so forth. The second thing is the me enterprise concept that has been, made famous by, I think, the LinkedIn founder or somebody like that, where they have to figure out how to go and excel at what chosen field or profession they have chosen, because the world we live in today, education and training is accessible from the best institutions to anybody with an internet for free, right? So it's more about the passion. Now, having said that, to answer your original question, I think, the students that we find are not quite ready. I've got some stat from our head of campus recruiting nationwide. Less than 10% of the students on campus recruiting that enter our funnel actually make it into our company through the tests that we give and the interviews that we conduct. And of those 10%, after we have given them 3 months training, not a very large number are, what we would call as supremely talented and great kids. So where is the gap? I think I agree with Karthik on the foundations are often found lacking. And that's more of, we have to look at the curriculum as well as, the teachers and the quality on all of that. But the second piece is also, I think, there's a gap between, foundations, and then there is what is practical. So in some cases, maybe that Python example was apt in the other direction also, where you have a student who comes in who can write a program to solve a data structure problem, but they don't know how to do that in an environment where you require, setting up the entire SDLC environment, running automation on your test, even debugging in a methodical and a systematic way, using the right tools to do this, right? So now we can debate whether the teaching these tools is academia's responsibility, or should they only focus on foundational. I'll leave it for the rest of the hour, but I think that is another thing that we find lacking: practical, industrial grade programming.
Thank you, Pandurang. I think I, in a lot of ways, agree with what Pandurang and Karthik have already stated. I'd like to just step back a little and also focus on the output or the students that we saw about from 5 years ago to now. And I do also see that there has been a positive change in the way, students are performing from what they were about a few years ago. And the 2 major changes that we've seen happen are that there are electives these days in colleges which are very focused towards the newer and emerging trends as well. and students who are not just encouraged by colleges but are also driven by themselves to participate more in hackathons or do some more hands-on projects and stuff like that. But having said that, I think the gap exists, probably has existed since years and may continue as well, right? So there has to be something which is more programmatic in a way that academia can continue to produce students that are actually needed by the industry. And I would like to a little bit step back to tell you all what industry has gone through in so many years and what is it that we're looking at in future. Well, it's something that most of us know, but it's in the context pretty relevant. So if you look at the industry from many years ago, things were very static in organizations because the society itself was very static. Many of us are probably from that era where there was just one channel called Doordarshan to watch, maybe one landline telephone at home. And if something went wrong, people were patient enough to, get it fixed. There was no need for, such cool tools, innovation, speed, and everything. But the changes in the society did put back a push on the industry and the technology, and then came the digital age. And industries at that time, especially the ones that were very well established, like many of you all may know, Kodak actually had some of the largest use of photo paper and about 170,000 people employed in about 1998 or so. Similarly, there were great brands like HMT, maybe Bajaj, and so many, which just did not survive the change because digitization and change brought about a need for everybody to change. So all I'm trying to emphasize here is that transformation is important. And those brands at that time that could not sustain that transformation or pick up transformation did not sustain beyond that. But with digitization came not only speed, but also a need for more speed and also a need for the way industry worked within, which means more flexible working, a flatter organization, more independent decision making, and acceptance by management and industry for others to make quick decisions autonomously and so many other things. So obviously, the age where only technical skills, programming skills alone were enough, brought in the need for students to be equipped more on the behavioral skills as well, and have more teaming and things like that, which would enable them to work from any location and be flexible, to be part of pop-up teams that came up suddenly. So things in organizations also became very fluid as against those that had a defined mission in the past, defined teams, a defined way of working, job roles and everything. And now comes the further push on the industry to continuously keep innovating to stay relevant. And obviously that means that the students that are coming out need to have critical thinking skills and be very innovative in their approaches. Again, that forms one part of the tests that are conducted to take students in. So there are behavioral skills, and there are coding skills, and then there are communication English language skills, which all together have become very important. Nothing is less than the other, in my opinion. But given the advent of the industry, the way it is today, and what is expected from the industry in the near future, all of these will continue to stay relevant. And I'm not sure if you've heard of the term new collar skills that has been coined by our CEO, which actually has all of these skills combined. And even for students who don't have a full 4-year degree, maybe a 3-year degree, can have a combination of all these skills to be very relevant to the industry. Thank you.
Yeah, hi, good morning everyone. It's great to be here amongst all of you all, and thanks for the opportunity. I'll talk mainly from the Goan ecosystem. Been part of the academic system here, studied in Goa, spent a lot of time working in Goa, been involved in recruiting a lot, the freshers in particular in the early stages. And I see a change, and I think the first 7 years we are a company, and when I talk about the Goan ecosystem, just to give a context, Open Destinations and Persistent Goa are top employers in Goa, and between us we have around 1,100 odd people employed, and overall number of companies is large. We have around 150 plus IT companies in Goa, but total number of people employed across all would be somewhere around 400. So I think just to give you an idea of what we have in Goa, but this will change, and it's going to require a lot of people, and that's going to be a challenge, because while this has changed, we also see a change in the education sector, and I think that's something we need to take note of, how the education sector has changed over the last 10 years in particular, to meet the changing demands of the industry. So coming to the industry and the question that was asked, we as a company, I think, started here. That point of time, we had a very limited number of resources available in terms of people. So we had 2 engineering colleges here, who were the main source of employment for you. And the way you get into the system and get out of it was, very much controlled, and we had some of the best people available for us. So in the first 7 years of our existence in Goa, if we required 10 people, we probably would, get around 12 people to be interviewed, 12 to at the most 15 people, and you had your 10 people with you. It changed over the last 7 years or so, wherein it went to, from 20 people for if you wanted 10 people, you had to go through 20 people to 50, and then it came to a point wherein it was 100 plus. So we had to go through 100 plus people to get those 10 people. And there was a decision made at one point of time that we will not recruit the freshers, the passouts. We'll only go for people who are experienced. But then we saw that that's not really working us. So we waited for 2 years of time, and he said it's not working. So we did an activity wherein we looked at potential people, and we did a workshop for them. And then we called it a boot camp. And after we did a boot camp with 20 people, we put those 20 people to the team for interviewing. And from that team, they managed to get their 10 people that they wanted. So we started that as an activity, investing in the students who are passing out, training them for some time, and then putting them across to. So that was a change as an industry that we incorporated to meet this. But what we did in parallel was reach out to the colleges to see what the problem is, and because this is something we need to address as an ecosystem partner, where the key input to the industry is going to come from. And we realized that a lot of people who are getting entry into the courses, because by that time number of engineering colleges were more than double. So we had 1 or 2 engineering colleges. Today we have 500 engineering colleges. So there are 2,000 seats available for in the engineering colleges in Goa. Which is almost the same number of people who pass out from there, slightly less than the number of people who pass their 12th science. So effectively everyone can become an engineer. And the problem today is that most of them who are in there don't know what they're doing, why they're doing. So we have a situation wherein more than 50% of the people who enter the course don't know why they're doing engineering, or they definitely don't like programming. So in the last few campuses that we went, I think the first question or starting point for us is like, those who like programming come this side, those who don't like programming come this side. And that's how we start, because I think there are clear opportunities for people in the non-programming sector. And I think that's where we need to focus on separately, and where people are interested in programming, we need to probably look at how we tackle them separately. So probably as we move on through this session, we will have some ideas as to what we can do there. But I believe like how we had these in the divisions in school, wherein A division, B division, C division, wherein you would group people, and the way you teach at times would also be different. Maybe that's required in this new education system, wherein you start creating clusters of people who can be trained as per their needs, their interests, and get them to be good, so that they become employable, they get direction, and they should not have to think after 4 years of engineering, what have I done, what am I doing, and that's not what I wanted to do. So it's a 4 valuable years that you spend, and I think as an education sector, we should be able to guide them, involve the industry, and that's what I believe is going to be the output of this, and make sure that we give them opportunities, we give them options, and probably make sure that they are thankful to what they got during those 4 years of education in the system.
Yeah, thanks. There's been a lot of interesting points that have come up. Yeah, so a lot of interesting points that have come up. I'd like to focus on one of them to start with. One is he said that there has to be a stress on foundations, and the other one was that there should be access to the ability to use current technology effectively, be able to use hash tables where appropriate instead of having to reinvent the whole thing. And that I have seen is a big confusion for the academic institute. They really don't, they're unable to decide what to focus on, whether to focus, how much to spend on foundations and how much to spend on academics. So taking programming languages as an example, because that's common to everyone. There is a need to know programming, what Abhiram has been promoting, that you need to know programming concepts and other things. And whereas there is another skill set which is needed, which is be able to use available libraries, Google for code, just put them together and get a solution in place. There is this balance that needs to be put in together. So what is your view on how that balance should be struck? Or do you think that only foundation needs to be focused on? You really don't need to focus on the learning 20 languages. And yeah, we can start from there.
So I think continuing from, I think it's more about making someone understand why is he doing it, or more importantly, whether he really wanted to do it, and is that really what is going to give him that kick, I would say, to spend a lot of hours in sitting in front of the computer and doing that. People want to do programming, but when they want to do it, they really don't know what that programming is. So I think from the faculty perspective, it's about how do you create that interest. So person in the first year, in the first 2 months of his entry to the education system, if he is not liking programming, it's very difficult for him to be a good person into that field. So there has to be something that triggers of that interest, and it's a challenge as to how do we trigger that interest, but it's very important that we either get people who have that passion for programming or create that kind of a passion. Now there are different ways you could probably go about doing it. It's about the team of people that you work in, it's about why you want to do it, what are better ways of doing it, and I think obviously we are bombarding them with different technologies. So from the faculty perspective, it's very important that you get the fundamentals, you focus on the fundamentals, and then let people, I think it's very important today that we teach people how to learn. Because today so much of information is available. So when you say that, okay, use Java, they will tell you why not this, I want to do this, I want to do that. So I think the focus should always be the fundamentals, and I think it's very, very important. So first year should just be fundamentals. One of the things I realize in the engineering colleges, the pain point of students is that they have to learn many other subjects than computer science, which they really don't know why they're doing. And I think they get less time to spend in front of a computer doing programming than they do all the other stuff. So they don't know why they're doing it. Like for example, so many mathematics subjects, like why do I have to learn all of them? Management subjects, why do I need to do all of it? I need more time to do my programming. I need to spend time in the lab. I'm not getting it. On the other hand, there are people who already made up their mind much earlier that I'm not going to continue doing programming. So what are the options for them? So as of now, again, very much limited to what I understand from the ecosystem here is there are two options that they know. If I know programming, I'll do a programming job. If I don't know, then I'm going to become a tester, right? And there is a third category who want to become an entrepreneur, who want to, have family business to take care of. So these are the only two things most of the time they would be knowing, testing or programming. Now, testing again is, so this is something very interesting that I talked to some of the students, some of the staff members, is that people who like programming do programming, people who don't say I'll do testing. After 2 years, 4 years of testing, they say, oh, I'm not really enjoying it, I want to go to the next level and I want to do automation testing. So what are you doing? You're going again to the programming aspect of it. And the guy who's gone into programming, there are some who would say that, I'm really not enjoying this at this stage. Maybe I should, switch over. This is too taxing, having too much of stress. Let me go on to testing. So I think these are things that many times people I find are getting stuck. But sticking to the initial point that was asked, I think it's about how do you create that passion? How do you basically get them to understand the fundamentals, and how do you get them to how do you get them to basically make sure that they focus on fundamentals and not get driven by so many things that they see around with their seniors, with their other colleagues that are there, saying that these are the technologies that are happening around. You should focus on that because there's a lot of influence. We work on these technologies, you're still studying this, don't study that. So there is a lot of things. So today's generation has this challenge in terms of they have too much things to look at. And then there is a lot of distraction. So how do you keep them focused? So that's equally a challenge. How do you keep students focused? But more importantly, as a teacher, I believe it's about being able to reach out to them, is being able to make sure that they can reach out to you and see that they can seek that guidance. If they don't know, if they don't really understand and they don't like it, they should probably come and talk to the teachers and see how they can probably help them either like it or take a different option that they can focus on. Just being there to just get my degree, I think, is not heading us anywhere. And that's where I feel the teachers have to play a role. They will have to interact just besides teaching. They will have to basically be a mentor to them. And I think that's going to be very, very essential to create that passion or get them across to someone who can help them create that passion. Because there are too many things happening. And I believe the teachers should basically are the right people, and they are the ones who should get them to focus, one, on understanding why this is important, what you will achieve out of it, and what you should be doing. If you want to do certain things, how you can go about doing it. Students should be able to realize that teacher is the person I should look up to for helping me, right? Rather than just saying that I'm just covering my attendance, and once I'm done with my degree, I will do something else, or doing some parallel consultancy. I think this two-way communication, if we probably focus on, it is possible that we can see a change in the way things are happening. That counseling, consultancies, much earlier throughout those 4 years of engineering that one does, I think it's going to play a bigger role, and it's going to be required. Because if one industry that's I see going to get disrupted heavily in the next 4 to 5 years, is going to be the education sector. And that's if it's not going to get disrupted, it will going to create a problem. So that's something I definitely see from my side, the biggest disruption happening in the education sector in the next 4 to 5 years. So yeah, I think a lot of things for us to look at and think about how do we deal with it.
Thanks, Milind. So I would think that students today need to be prepared for the past, present and future. I know the past sounds a little weird. The reason being, a lot of people and clients actually use and have invested a lot in hardware, software of the past, which needs to be maintained. Secondly, nothing becomes really past when it comes to computing. The concepts and basics remain the same, which need to be adopted going forward. Nobody can really just learn to use high-level APIs and things like that, but not know what is the basics, but that is what is happening. A lot of students come with the expectation sometimes that they will only be working on those roles. But we like it or not, the basics are used in most of the roles that are there today. The roles that don't use the basics are really very less. That is something that even students would need to understand. So I totally agree with the fact that we need to have basics in place and also more tailored towards the industry, which means that teaching and learning by students has to be a lot more experiential. Obviously, the industry is doing hands-on on a daily basis, but the amount that the student is doing in the 4 years is hardly, coming to a few days of what would have happened in the industry when it comes to the hands-on. So the hands-on component, the experiential learning can be increased manyfold. I think in some ways, it should help bridge the gap. But I also agree that the student and teachers already have a very tight curriculum. A lot more is getting added onto it. So, how do you actually address an issue like that, where people are fully packed already? And there's a lot more that still needs to be done, and people are still stretching to do more. So my own personal opinion on this would be that if the curriculum can be in some ways reduced, so to call it a fixed part of the curriculum and a variable part of the curriculum, and when it comes to variable part, maybe a year or year and a half of the whole 4-year degree is kept variable, which can actually have more experts from the industry or students going to the industry and working. It is also more meaningful for the industry itself. Today, if a student works in the industry for, let's say, 2 months or 3 months of a summer internship, people have to teach them quite a lot before they're actually ready to be productive in any way, which is not a very useful thing in general, and hence it's not being a win-win in some ways. But what becomes more of a win-win is if a student can be made available for a longer time to the industry, and have a lot more hands-on, then they are already ready when the industry takes them on. So it's useful for the student as well as the industry, and also hopefully puts a little less pressure on the faculty to be continuously trying to get the students up to speed. So the faculty also are going through a lot of trainings. I know the faculty development programs, there are sessions such as this happening and all that. But the entire onus, I think, should not just be on the faculty, according to me. It probably needs to get divided amongst the students, the faculty, the industry, and if everybody owns it up together, it should be able to bridge that, what we are looking for in terms of the experiential learning and the programming basics, like Karthik and Pandurang also mentioned.
Sure. Thank you. I just realized in all this that we don't have any academic representation on the panel, so I don't want us to turn into an academia bashing panel as well. So Professor Ranade and so many other academics here, please keep us honest on this. I think there are different types of education models here. There are engineering colleges, even within engineering we have computer science and we have IT now. There are BCA courses, MCA courses, and then there are schools like Lambda School, right? Everybody has heard of Lambda School here? Okay, so this is also coming to India, by the way, slowly. So Lambda School is an interesting proposition where this is a startup which says, anybody can become a good programmer. They are not training computer scientists, they're training effective industry programmers. So you can be a waiter, or you could be an accountant, and you could come in, do a 10-month full-time course with Lambda School, with assignments, with training. They start with foundational, but then they focus you on a particular industry job. Let's say you are a Python programmer or a web developer and so forth. And at the end of it, and they invest in you, I think they don't charge anything. Once you graduate, they guarantee a job. Once you get a job in the industry, you have to pay back the fees, so to speak, from your salary. If you don't get a job, you don't owe them anything. So that model is kind of catered towards filling this industry gap that we talk about, right? So there are different models is what I was going for. And if we focus on engineering colleges per se and computer science particularly, I think the primary goal, I would say, for that sector should be to lay the foundations. And that should be the primary goal, but not the entire goal, right? So the focus should be on making sure the foundations are right, because no matter, I can take a good computer science graduate, fresh graduate, and in 2 weeks, if they know how to use cloud, basic cloud, we've actually done this. In 2 to 3 weeks, people can look at the AWS ML models, can look at IBM Watson, and integrate all these things through API and get something running and get you 80-90% of the way there, right? But in getting a machine learning model from 90% accuracy and precision to 100% is like 99% of the heavy lifting. And that heavy lifting you will not be able to do if that individual has not learned their basic mathematics and probability theory and the algebra that we learn in engineering and so forth. So I think that the predominant focus should still be to solidify those foundations and prepare them, teach them how to learn, as I think you mentioned, I don't remember which one of you mentioned that, teaching them how to learn forward. And in the labs portion of that education, make that a little more pragmatic, right? In labs should not be about this command line compilation, I can write a compiler and get the code and it will work. In the industry, you're going to have an IDE. In the industry, you're going to design APIs. So having some of those elements, setting up an environment, are we doing this on Windows or Linux, what is predominant in the industry, maybe giving a flavor of both across the 4 years, giving a flavor of how to use cloud services, giving a flavor of how to create DevOps automation, giving a flavor of how to use debugger the right way, a flavor of how to use profiling tools, right? These are, you wouldn't create a civil engineer who doesn't know how to stress test a bridge, right? But we are creating computer science engineers who don't know how to profile a program, basic profiling, not the advanced stuff. Some of this should be thought of as whether it can be incorporated in the labs. And going back to Milind's point about maybe some of the first year courses, I don't know if they are still in play, but I remember learning chemistry and physics and economics, which I don't think really the curriculum has helped. I don't know if they are still around in the first year. Engineering graphics for a computer programmer, I struggled a lot over 2 semesters, still get nightmares. have no idea why I did that, right? As a computer science program. Maybe some of that time could be utilized in and repurposed for this takes. Don't get me wrong, I think behavioral economics, psychology, and some of these elements are extremely important when you build consumer-facing products as an engineer in the market. But I don't think we are doing justice and setting up the right curriculum in those things. And I don't think that maybe is required to be done at the undergraduate engineering level as a must. It can always be done by product people, because a lot of engineering graduates should and will go on to become computer science researchers. A lot of them will go and become faculty. So we shouldn't only be catering to mass industry or product engineering as well. So that balance has to be struck.
So to add to three of them, right? So one thing I've seen, at least from the courseworks that we've kind of dealt with the universities, is that each course is independent of its own, in the sense that you do a course on data structures, you learn how to find the O notation, this is O log n, O n log n, all of that is great. Then you go to the networking course, and then you send some packets and you do all this stuff, but you never say, hey, when I send this packet out and I do this HTTP, whatever processing stuff, is that running in O of n log n? We never bring that into this, right? So I work a lot in the security area and the secure coding and all of that stuff, and I know that there are courses, there's a single course on security, and then that knowledge that is gained is never applied in any other course, right? So basically, the students think of all of these as, this is independent, this is independent, so you learn security but never apply it to networking. You learn data structures but never think about it in the context of security. So you never tie, there's nothing that ties them all together. But the industry is all about tying everything together. I cannot build an Uber without the security part of it, the performance part of it, all of them put together, right? So there is no layering that basically says, at the foundation you learned about O log n and O of n log and all of this stuff. Then the next course has to use that, right? And then the next course has to use that. So by the time you graduate, you built a single Uber, let's say, right? When you graduate, you potentially built an Uber that effectively has used cloud computing, it has used machine learning, all of that stuff into a single product. If you think about that, then every student who leaves college in that 4 years is enough time to build a company. Right? If we basically layer the education in that way, then at the end of 4 years, every student who graduates has effectively built their own company with the software that covers all of the layers that they've basically learned, right? As opposed to every course being independent of each other. So today when I go talk to a student, he says, I ask him to build something in networking, he draws something, and then I say, but you're missing the security part. And I say, but security is different. Right? Security is not different. Security is part of the same thing, right? And then I tell him, oh, you missed, something here. Oh, no, but that's a completely different thing. No, nothing is different. In a single product, everything needs to be tied together. Unfortunately, that is not there. And for this, I won't blame I won't say this is academics' responsibility. It's all of us, right? It's basically the industry's responsibility also to go and say, this is the kind of stuff that we built. Unfortunately, we don't share our secret sauce. So we don't, people don't know how all of these things tie together, but that's the foundation. The foundation is basically going layer by layer and saying that at the end of 4 years, every student could potentially have started their own company, because that's how long it takes for a startup to go from initialization to an actual product. If you think about that, and basically we tell the students at the end of the 4 years, all of you will have a product that you could potentially go out and sell. Maybe that makes sense from both an education and an industry point of view, right? So,
yeah. So I think that's some points that I'm going to pick up on some of the points that have been raised. And I believe, as far as academia is concerned, they are going to say this is quite an immature industry. They just expect the same student to have all kinds of skill sets. So if you look at the banking industry, they have solved the problem. They really don't say the education system is not really producing best finance-trained people. They have succeeded well. They have had great banks. They have done really well. But take a look at the manufacturing industry. They have very clear categorization on whom there are diploma courses that they have influenced. They take diploma courses for specific roles and specific targets. Whereas this is the only industry that expects the same guy to do testing, the same guy to do sales, the same guy to do So the whole problem is that the industry is not matured and hasn't yet built roles for itself and started recruiting for those specific roles. Instead, they say, we want CS computer science graduate. We won't take anyone else. Banking industry doesn't take just finance people. They take everyone. And they have very successful banks. And the numbers they employ is comparable, if not more than what the IT industry does. So what would you say to that?
So I'll start off. Actually, that's a very good point. So one of the first things like I said, I meet a lot of the new hires when they first join Cisco, and one of the first questions I ask them is, along with the computer science students, of course, this would have been their friends would have graduated from civil or architecture or any of these, and I tell them, now that you've graduated and your friends have graduated from civil and architecture and so on, how many of you would let your friend build your parents' house, right? At this point, at the moment that they've graduated, nobody would raise their hands, right? How much time do you think must have passed for your friend before you would let them build your parents' house or your house with where you would put up your wife and kids and everybody? And they'll say maybe 15 years later, right? I'll wait 15 years for my friends to gain whatever experience and exposure they need before I would let them build my house. But as you say, in the software industry, we're expecting fresh guys to come on board and immediately build something huge, right? That's something, I mean, that expectation is there from both sides. The new hires also feel that they come in and they'll immediately be doing something really awesome, which is not going to be the case. It takes time. It takes time to build all of that stuff. So I think this is where we say software engineering, but truly we're not engineering. We're like black magic. I mean, we have no idea how things work in reality, right? And engineering needs that kind of discipline. I think if you go back to the real engineering, civil, mechanical, all of those, and maybe that's the kind of stuff we should be looking at. And we need apprenticeship, right? And internship is basically an apprenticeship. We need all of that stuff built together, and in 10 years, hopefully, we'll have a very good software engineer. We have to think about the fact that our careers are 40 years long. Right? It's not like we work for 5 years and then retire after that. That's not how things are, even though a lot of people aspire for that. But, you leave college at 21, 22, you're going to work till 65. That's a 40-year career, and you need to be able to build to that level. I think that makes a lot of sense to basically say it'll take 10 years before you get to a point where you can build something that's really, really great.
Yeah. Today, after 3 years, he starts programming.
Yeah. So I think, thank you for bringing that point out and keeping us honest. So I think I don't have a whole lot to add other than I know that Persistent, for example, and a lot of others, Infosys, TCS, have been running these programs where you kind of try and influence either the curriculum itself or you conduct sessions for a subsection of the engineering graduates where you kind of lay down some of the foundations or strengthen them. So we have this thing called Persistent Computing Institute, which does this largely in the Pune ecosystem. It's a smaller scale thing where we run summer schools and winter schools for select students. We haven't yet figured out how to scale that model entirely. So somewhat the industry is doing it, but I don't know that I can say much other than accept that what you're saying is a fair point. It is also the responsibility that we have, that we shouldn't expect everything from get-go. And again, I think there is a lot of anecdotal experience here that when each one of us on this panel has interacted with students, and my initial reaction was, yes, the typical typical old person reaction that I am on the other side, now I'm the older person, and this new generation is not trying hard enough. And this, it took me 2-3 years of doing that interaction to realize it's actually not that unidirectional. There are with the advent of GitHub and all these Hacker Earth and all these competitions, you see a lot of students with real passion doing a lot of things that we did not do, and therefore that makes them a stellar candidate both from foundation and practicality. But then the advent, particularly in India, of the large technology services giants who will sweep in everybody and then train them, also means that a lot of students simply don't bother. They know they'll get a job. If I have this university tag, I'm going to be picked up by one of the 4 or 5 biggies and trained, and I'll have a job in an AC office somewhere. So unfortunately, the key thing would be for industry to start influencing at scale. And we are doing small pieces of it, but maybe it'll take another 5-10 years for us to get there. Yeah.
Sure. Yeah, so I think taking off from where Pandurang just left off, I think it is true that, there is a lot that the industry still needs to do, because obviously it's not as settled an industry like what Venki just said. I mean, banking has its stuff, right, and they're doing it all, and then IT has been kind of still struggling. It's on the learning side for IT as well, and which is why a lot of IT companies have to do put in a lot in terms of training students who come in, those who are actually, not able to obviously perform on the day 0 or day 1. And hence, I think what IT companies, especially services, are looking at is how can students become more productive very soon, instead of investing maybe 6 months of training time or 3 months of training time. How can that actually be reduced? And the obvious thing is for the industry, and I think we've not done a great job at that, I agree, to come forward and influence the curriculum some more. In pockets, some things have happened. We did work with, let's say, AICTE to put together some, and with NITTTR to put together some of the curriculum for, let's say, IoT or cybersecurity, some of these which are publicly available on the AICTE website and stuff like that. But it is a learning process for the industry. It's still an ongoing thing. We're very far from where we could get. But some of these things, like maybe we influencing the curriculum, helping faculty get up to speed, helping with more of these real-time projects, real-life projects that happen in some colleges. I'm sure in some of your institutes also, you all must be having this concept of come in with an idea and walk out with a product kind of thing, where a student comes in with an idea, and like someone just rightly said, that it's enough to have a startup running in about 4 years. So I do know of projects like building up of a solar car right from scratch, for example, that students from across many departments work together. And there is electronics, there's computer science, there's mechanical, there are so many coming together, and also support from the industry in terms of mentorship, maybe funding sometimes. And then by the time they finish, the solar car is actually ready to run a race, for India or somewhere else outside India. So those are some of these things, and I'm sure some of your colleges have this. I think what we as industry probably need to come forward is to help out some more with that. I think what I'm trying to say is that please reach out as much as possible to the industry for such things, where people are, even at a personal scale, willing to mentor for such things, and see how we can bridge the gap. We are definitely far from, where we should be ideally.
Well, I have a different take on it. I don't think that's a fair expectation that will be, met even in the next 5 years, 10 years, in terms of, being able to put that structure. It's because the demands and the changes around are driving us in a way that you will never have time to settle down and put all the things in place, that you're expecting. One of the reasons the industry has, I think the industry has grown fast, and that's where the requirements and therefore the number of seats increase, and getting everyone to become the people who can be inputs to this particular industry. And then the students who do their programming or the computer science are the ones who will be expected to know anything and everything, like how the students expect a computer science teacher to know everything. There's no specialization. They should know anything and everything. Similarly, a student, once you enter, in the IT world or any world outside, people expect you to know anything and everything. It's much later you realize, oh, this guy is, specialist in this and that domain. But what actually ends up happening is many of these same students over a period of time become domain experts. Right. So today I know friends to a very in the initial stages I didn't know whether that person was a doctor or not a doctor, because he knows the medical industry so well. He's got these ECG machines. He's in IoT and he's got those ECG machines that he's worked on and developed. But he's understood the domain very well, so he's very comfortable talking all those terminologies. To a very long time we didn't know whether whether he's really a doctor or he's an engineering student. Similarly, in finance and other domains, you will see people understand the domain very well. And one of the points that we talk, to be introduced in the academic system is about the domain knowledge. How do we basically give them exposure to the different domains that they may be interested or wanting to know. Insurance, for example, or the travel domain or the finance domain, the banking domain. So it's very important to understand a few of the domains because the opportunities exist there as well. So. How do you then, in this, with this background, what you expected to do is keep on delivering, innovate, embrace new technologies. And where are these demands coming from? It's coming from the market, it's coming from the other domains that are there. And you as an IT company with the same people are coming in, you're expecting them to be part of that system. And we show them carrots, we show them growth, we show them the opportunities, and we just expect them to deliver. Right, so I think that's the nature, and I really don't know very honestly whether this is going to change and whether there will be attempts made to change it in the coming very recent future. So people are going into this particular domain, or rather the computer science and programming, because they know that there is an opportunity there, right? Whether they'll be able to get out of it successfully to meet that expectation is a different story. But initially, it's their parents, whoever want them to get into computer science or IT, is with an hope that he is going to make to one of the big companies tomorrow. He's going to create a good life for him. He's going to become someone they can be proud of, and he'll be well settled. So I think that's one aspect. They go in knowing that, so there is big packages waiting for them and all that kind of stuff. So there are a lot of drivers. Who provides all of those? The industry provides, like, yes, come, we are coming, we will give this competition. So on one hand, we do that. And then obviously when you're paying so much, you're going to expect them to perform. You're going to make them work, slog and, deliver all of it. Now why that thing happens is because the other clients and the other domains are expecting you to deliver to those timelines. Like for example, we are a company who have a travel software. So our clients are tour operators. So some of the biggest tour operators in the world use our system. Now it's very time bound. So if we have a client whom we have to deliver, it has to be delivered on a particular time frame, so that before the season starts, they are ready with the system, they moved on to their production and they're ready to take bookings. Now that means that if we have to get money to our table, then we have to commit to certain timelines. Sometimes it's a very tough timelines. So how do you basically afford not to have people who are having that attitude that yes, we will be part of a team that will be slogging to deliver and meet those timelines? How can we have people who are not skilled enough to get and work on a project? So I think all that comes, and of course they get incentives for all of that. So I think industry is creating this, to make sure that you get people to work and deliver. How do you basically make that structured? It's probably going to lead to a work-life balance, maybe. I may be wrong, but that's something I'm not sure whether it's going to happen in the near future. But talking about the startups, which Karthik mentioned, I think that's another challenge because today everyone also thinks that they want to do a startup. So I think if that does not happen, maybe I'll look for a job. So a big chunk of those people go with that thought process. I would rather say that, let's encourage something wherein we also get people to continue working on projects done by the seniors. This is something we don't really discuss, because everyone who comes in wants to start from scratch. Right? In reality, when someone comes and works with us, he will work on an existing stuff. So we will train them, and then he has to work ultimately on a bigger project code. That I don't really see happening. So it's not just a 4-year startup. Then you start, someone else continues, and then it becomes a bigger stuff that we can talk about. So that is something I don't see how we get that into the system. But I think it's a very, very interesting question. There will be definitely different views on it. I just put across my views because I honestly feel it's not going to change. The demands are going to continue the same way. And I don't see any honest efforts from anywhere towards stabilizing it, because that would mean probably a lot of delays and deliveries, which is never going to get accepted in general. So the demands will make you push towards all of these challenges. It's about how do you basically balance out and be in a system wherein it's a win-win for everyone based on their expectations.
Yeah. So I disagree on many counts that, so for instance, I really don't think the industry needs to demand a single degree or a single skill set from the banking industry, for example, is one of the biggest drivers of technology. And so, but we never recruit a banker. We say we need an engineer, and preferably a computer science engineer. That is what has led to the proliferation of computer science degrees in this country, because the industry has really influenced us, which I don't think it need to have. And but that's a debate that can go on forever. And so I'll let it there. So it's the industry which is really messing up with kids, is what I feel. And so the next question is, we have very little time before we throw it open to the audience. Communication skills is another soft skills. Communications, the ability to write and all that are another area where there has been a lot of debate, even in the conference in the last couple of days. So what is your view on communication skills of students and what can be done to improve them or whatever?
I think it's again very important. We do spend time in having those separate sessions for people, and I believe now most of the colleges have them as part of the additional courses that they offer, because everyone realizes it's very important. I've had cases wherein we had very good programmers who were missing out on overseas opportunities because the communication was very not good enough. So I think we have spent time with such people, giving them that extra coaching or guidance and help to make sure that they don't lose opportunities because of that. And I'm glad that there are many such success stories, wherein people have done well. They've not only excelled, in what they were to what they are now, but they have traveled all over and been able to make a big impact. So I think there are people who will always need help, and it's a welcome help. I think this is something we assume that people will learn or not required in our syllabus, but I think it's very important to get people trained on soft skills, and I think that's coming up. I see that coming up in a big way in most of the places. Most of the companies have that in their own orientation programs. So I think communication is very important. I think there is attitude, which is also equally very important. I think that's something that we have to see how we can put that into the students' right attitude, because that's been a big challenge many a times. Getting people with the right attitude to come and work for you. So I think there is no dispute on the need for communication training. I think that's most essential, and I believe there's enough work being done. I think the communication is much better. At least the ones that we deal with here, I think is much better. I think we see a lot of improvements in there.
I think communication skills is no longer optional. It's become one of the very key skills, just like programming and behavioral. We do see a lot of students not being able to communicate what they can do to the client, or not being able to work with teams that are now coming up across India geographies, because teams are not now limited to just any single geography, and things are becoming very transparent and flat across in the industry. And hence communication, written communication, oral communication is really not any optional thing, which is why now in our tests at IBM, we have introduced this as one of the mandatory exams to pass to get into IBM at the fresher level. And reason for that is that we did see that lacking. Very unfortunate that some very bright brains who are able to do something so good are actually not able to communicate within their teams with the clients and stuff like that, which definitely impacts business quite a lot. And that is the reason why this got introduced, and we don't see too many students being able to do that great in communication. I do personally think that there's a lot more that also needs to be done, because students come from all places, tier 3 cities, towns, everywhere, because they are now looked at from their programming skills and things like that. They are able to clear some of those very well, but because of this, they are unable to make it to some of the big jobs. Even if they make it, the success factor gets deeply impacted. So I do think there has to be some sort of a system in the way that a college can also continue to reinforce English language or basic written communication, oral communication, and things like that within the system. It should ideally not just get stopped at the school level, is my opinion.
Sure. I think I'll broaden the scope a little bit. I think there's a set of soft skills, if you will, or essential skills. Actually, I don't enjoy the term soft skills as much. Kind of depreciates the value. I think it's communications is one, collaboration and team work is another. It's not about the individual. In fact, in our orientation, at least in my team, early on I give an example of Kevin Peterson. Those who know cricket, one of the best players in the England team at the time, he was kicked out of the England team because he was not a team player, right? And he was the star player, singular, most talented player at the time. He was kicked out. because he couldn't work with the rest of the team. So the collaboration part, there is empathy element to it. How do you empathize with your collaborators in your team? How do you empathize with the customer? How do you empathize with the end user for whom you're building the software? And then there is the ethics part. If have seen Jurassic Park, the original movie, there's a dialogue in there, your scientists thought so much about what they could, they never stopped to think about if they should, or something to that effect. And this is going to be paramount as we build more automation, as we build more AI-enabled systems, some of the things, whether we should be doing them. And many of these things, all of these are going to be joint efforts, but some of these, particularly like ethics, and empathy may not be always taught in the industry because it may run counter to their interest at times, and therefore academia could maybe chip in a little bit more on that. But I think the industry is doing a lot on improving all of these elements in our own training as well. I think it's some touching upon this through formal course. I believe there is one in the first year typically around communications, but then through the 4-year course, just giving students the opportunity to come and present in front of a class, giving them more collaborative projects, and talk about the elements of why have they designed this something in a particular way and how it impacts the end user. So softly introducing the notion of empathy into what they are doing and stuff like that would help in the academia. But this is a joint effort. It's not just unilateral.
Yeah, I like the term essential skills. I agree. I think soft skills is probably not the right way to phrase it anymore. I think it's really essential, right? So, so I've been working for almost 20 years, and after 20 years, I spend 10% of my time programming, 90% of my time talking, right? And it's basically, or drawing on a whiteboard or whatever it is, across multiple geographies, all of that stuff. So, I think once again we can look towards the traditional engineering and science-based, the laboratory experimental science-based stuff where everything is documented, right? In the sense that this is the problem, this is my hypothesis, this is what I'm experimenting, this is what I'm going to do, and this is the result of that, right? And even in the software engineering field, that's the key. It's basically a lot of the times we're just trying things out, and we want to put it that way. We want to say this is what I tried. This is the problem I'm trying to solve. This is what I tried. This didn't work. This didn't work for these reasons. This worked for this reason. This is the option I'm going to pick. Right? I think that's something that we absolutely lack. We, again, goes back to the traditional way of maintaining a log book and with all the experiments that's run. I think that's a very good way to do it. But yeah, essential skills, absolutely essential. Like I said, I have to know more English now than Python or whatever it is. So that's where we are. So. And PowerPoint, exactly, PowerPoint. Presentation, engineers think presentation skills are for marketing and management. That's not true, right? It's basically, it is the way to communicate. So we have to be able to communicate.
Yeah. Thanks, everyone. So now just open it up to the audience for some questions. And there are several hands. And so obviously not everyone agrees with what has been said so far.
Hi, Viraj Kumar from ISC Bangalore. So a former student of mine who now recruits for his company said to me that GPA is essentially 0 bits of information. So I want you to react to that by suggesting what can academia do better to help portray what students know, convey that to you, so provide you more than 0 bits of information. If transcript and GPA is essentially meaningless, and perhaps you agree, perhaps you disagree, what more can be done? Because I think today we don't need to be limited by a paper-based transcript. We can distill much more about what students do across 4 years and convey that to you perhaps in a machine-readable form and officially sanctify it through our process that this happened here and this student has done this work or this component of the work. Do you have some thoughts on that?
So I'll just answer that very quickly. We do a lot of, when we try to hire people, we do definitely Google them, I'm sure. If we see a lot of their code on GitHub, that's good enough for us. That's basically what we're looking for in the end. Right?
Yeah, I think we can limit to one answer for this because of the number of questions, but I don't think it's zero bits as much as I have found the contrary to be quite true often that, and we have cutoffs, for example, which I think are quite cruel, but at scale you need cutoffs before they don't even interview or they don't even answer a test on a campus. If they have below 60% across engineering, I think we go back to 12. I think that is a little bit of this because I have found some of the smartest people to actually fall below this, and we have argued and fought and brought them in. But I don't think it is zero bits, but what Karthik said makes sense. Yeah.
Okay, so I have a question about internships, but not internships for students, but internships for teachers. Would you be in favor of, I think a lot of the time, teachers are themselves not familiar with the kind of technologies that you're talking about, and I think it will have to be designed quite carefully, keeping in mind sensitivities of positions and things like that, and maybe, I don't know, I mean, but I think it could go along. What do you think industry, maybe through CSR, maybe through some other mechanisms, be in favor of that?
So it's a great idea, sir. I think, it's something that we should look at. It has been considered. There is no, I would say, no defined structure to it at this time, but it's not something that would not be considered at all. We do have faculty development programs, for example. They can just be, an extension to that in some ways and have something more hands-on to be done for the faculty to come in and do something. It's certainly something that is being considered and not something that, is not doable. Probably no structure at this time that I'm aware of.
Yeah, so just to give what's happening in Goa is that there is a Department of Technical Education which is now having the engineering colleges and the industries to sign MOUs. In the MOUs, one of the clauses is exactly this, can the faculties be, facilitated in terms of faculty internships, not just the student internships. So yes, it's very much required because they get engaged, because they have their own challenges, right? Because the students expect the teachers to know everything. I think that's a bigger challenge. The faculties require support, so that's a good collaboration which we believe is going to definitely help. Secondly, as an association, what we also propose is there is a 2 weeks of internship which is there. So as an association, our proposal was that rather than for 2 weeks, sending students to industries and just trying to do something, we will have the industry come to your college, we will run the internship in your own colleges, and we will certify as an association. So we'll have around 10-12 companies being part of a workshop in one college, others in another college. So that way what happens is engagement is more, the faculties can participate, the students can get some good ideas to go on. So I think these are some of the thoughts that we are working on, and the government of Goa, I think with DT, is actually driving in some of the MOUs these activities. So on 15th of this month, there is an MOU signing ceremony with around 100 MOUs are being signed with different companies, colleges, and the DT. So led by the CM of Goa.
Yeah, hello, I'm Lakshmi from IIT Bombay. So just a small two lines of introduction. So I have with me Prajesh, Deepthi and Kavya. So we work in the CS education research. So a small part about is what do we do on, like you were talking about, I'm glad you spoke about content knowledge plus essential skills that you were talking. So what in this essential skills is getting like muddled up is that, you have these person skills, personality, affect traits, and the other ones like Shivakumar was talking about, this process that you follow, the aim, hypothesis, so a structured way of thinking. So we work on something similar to that. So we work on design thinking, and some of us work on troubleshooting and all that. So what we aspire to build is this fungibility in the learners. When I mean by fungibility is this idea that given a problem, a similar problem in a far off, are they able to apply it? Like you spoke about, troubleshooting, I did this. It could be even done in design. I tried this, but this actually didn't work. So I want you to react on that. And the second part of my question is that there's a lot of research happening in the West in terms of, like Microsoft works with some professor in the University of Wisconsin, where they're trying to see what constitutes a good software engineer. This is a very highly cited research paper. So, where they look at, because we are still nascent stages of, you know, our industry is and even our research is. So what really constitutes software designer is they talk about traits, like, you know, you were all talking about. They're all broad terms, like ability to collaborate, but there is so much inside it. Ability to, you know, work in a team, there is so much inside it. So what do you think about that? Those are my two questions. Yeah, thank you.
So I think on the second question, I mean, the way we call it is the new collar skills. It's really important. It has many aspects to it other than, like I said, the programming skills or the technology skills itself. We have the ability to learn, adaptability quotient, and also the ability to team well, to be able to communicate, all of those that are coming under the same topic. And I think there are a lot of companies that are doing some research. There was very recently a research done by IBM as well, and a study that has been published on that regard. And that's where they came up with you know, all of these traits, like you rightly said, constituting the you know, software engineering role for a fresher, or even for that matter, somebody who's experienced. So you're very right about that. I think, you know, these are all important aspects. It's not just limited to only one thing as it used to be earlier, but even the one thing which is the programming or technology skills, it continues to stay important in today's business, given that they should be done from the very basics, and there has to be more applied knowledge of it in the industry rather than more theoretical.
Yeah. Yeah, I have a...
So we have at least 5 more questions. So when we have that, maybe after.
Right. So quickly, you know, about the academia industry gap. There is, you know, always a feeling that, you know, these two teams doesn't meet each other. For example, you were saying, you know, these academic people should come to your side and ask for help. Okay, so, and then, you know, the academia says, you know, these people are not, you know, coming from that side, you know, to this side. In fact, you know, some 10 years back, there was a campus placement meet. I was part of the Tech Mahindra, you know, team that time. So leadership was there. There were all placement officers there. One of the gentlemen, like our Dr. Natarajan, got up and they asked, you industry people will come to pluck out, you know, the flowers every year. You never come and, you know, nurture or water these plants. Okay, so this is a statement, you know. So that gentleman asked. It really hurt all of us. All the leadership who were sitting on the tables, you know, they got up and, you know, they suddenly felt, you know, so bad getting this question. So I see, you know, two major things, you know, missing, you know, from the academia. One is, you know, problem solving skill. The second is, you know, listening skills. Because people today, you know, if you give a problem to a student, he doesn't even listen to this problem. He immediately comes out with a solution with whatever he knows. There is Arduino board, there is this sensor, that sensor. He will talk about all sorts of sensors, but he doesn't even, you know, care to ask questions to understand the problem in detail. So I think academia, you know, need to really teach, you know, problem solving. Because yesterday, you know, the professor from IIT was saying 80% of the time he spends on, you know, his people to work on the problem and 20% solution. But problem, you know, as such, you know, our people, you know, young engineers, you know, students, you know, doesn't, you know, listen, and they doesn't reframe, and, you know, they don't understand the problem. They will design solutions which are very awkward, it doesn't scale, and, you know, so that's something, you know, which need to be this thing. And the listening skills, self-awareness, because many engineers feel, you know, they're all, you know, feet for, you know, playing with all these complex softwares, you know, this thing, and they miserably fail. So building self-awareness, problem solving, and then, you know, these things, you know, need to be, you know, looked at. And how, you know, industry can, you know, what you call, you know, proactively, you know, coming to the colleges, teach them, you know, through case studies. Which is the teachers, you know, doesn't have case studies, you know, much, you know, to reinforce concepts, but which, you know, you can do.
To answer it.
Right. I guess, was there a question there?
Yeah, that is very...
But I think it's a point well taken. Point well taken.
Yeah, so I would like to respond to that. I agree that problem solving skills and everything has to be developed, and I think the problem lies quite a lot with the industry, because when they interview, they ask, how do you write a program to do this? Instead of asking more general, non-technology questions like, here is a general problem, how would you try to solve it? And if that happens from the industry, I think the academia will automatically respond by training students to ask the question. Today the questions asked are, how do you find the minimum in an array? Students will be prepared for that. And so that, I think, needs to change from the industry side to say, lay stress more on that rather than the technology.
Yeah, so I think we should first start
thank Pandurang and Venki playing the role of an academic in that panel. Um, so, I mean, notwithstanding the fact that there is so much academia has to improve, there is too much theory, practical, memorization, concepts, learning, all that, it was refreshing to hear from Pandurang that he can get a smart student and get them to 80%, 90% up to speed on AWS in about 2 weeks. This is great, which means that we can go back to teaching whatever we are doing in foundations and do them in our, there is much room to improve, but we'll continue to improve that without worrying about are we doing anything wrong, right? And the second point, again, Venki, you brought this, very refreshing to see this banking industry. I was exactly thinking like this. Not only banking industry didn't bother, they are happy to take the product, train them, which is doable according to Pandurang, that it is doable in 2 weeks. And not only they did not bother, they did not come to the institutes and colleges and said, oh, your curriculum is all wrong, we're going to change the curriculum. And more than that, right? Placement. Every time Chitra brings this point that final year in every college, including in IITs, is a washout, right? Because semester they are preparing for placement, second semester they are partying because they got the job, right? So why can't they, organize themselves and come later for placement? So see, in a college like SSN, it's only the fourth year which is a washout. But I know in some private engineering colleges in Tamil Nadu, from day one, the regular courses are not important. They are all preparing for placement. And they are very happy that in their fourth year, whatever training is supposed to happen in the company is taught as a fourth year course in these colleges. And notice that, whatever learning, even if it is not very relevant, I mean, when we learned history and geography in school, we think about how relevant it is. Now, the 4 year is the only chance for most people to learn anything at all, right? So we are missing that entire opportunity, and banking industry didn't do that. So, okay, I'll just leave it at that.
So one quick point there. When I said the smart student part is as important as the 2 weeks part, right? So the point I was making is, if I'm hiring a fitter, they should not look at a spanner and say, okay, what do I do with this? Which side do I hold and how do I use this? So what is important for me is if there is foundation is very strong, and they are familiar and comfortable with the tools of the trade, contemporary tools of the trade, which is when I write a program, I use an IDE. When I write, I need to know Linux scripts or Windows script writing, right? So I can automate basic things. I can teach them, once you know this script, you can run this on AWS, you can run it on a VM. People look at a VM and they have never seen that in their life. That should not happen. If you give the foundation, strong foundation and basic comfort with the basic tools, we can actually create expedited, targeted trainings for what industry needs, when they come on board. That's not a problem. And inquisitive problem solving is extremely the single most differentiating skills across the engineering spectrum up to the first 10, 15 years and even beyond. But those are the ones who really shine and can accelerate through their career if they have that inquisitive problem solving, because things are changing so fast that everybody has to read documentation, understand, experiment, fail, sometimes fix the documentation, fix the tools that they're working with. And that is the single biggest tool that comes. If a large majority of people, if you don't give them precise things, they will not be able to do their job. And that's a challenge. Not just with freshers, even after people come on board and spend a while. Yeah.
I think, I think as you mentioned, the point is placements, I think that's where a lot of things are also coming in, playing a role. Because colleges today focus on placements. It's very important to give students placement, because you probably, see, it is not the scene earlier, because you were just focusing on teaching. Placement was not really the core thing that a college was responsible for. Today, college is held responsible, accountable for making sure placements are there based on where you're able to place, how fast you're able to place, what is the package you're able to give to your students. Colleges are basically being preferred. I think, see, this is also one of the drivers, and we cannot ignore this context. So I think as long as that's going to be a priority, the industry will be asking for making sure that I get the right thing, so that the best thing, so that I can get best from them, because it's an investment. So that aspect cannot be ignored, the entire placement scenario.
Okay. So with so many questions, I'm going to go by my perception of the sequence in which the hands were raised. So.
Thank you, sir. Okay, my name is Razia Sardinia, and I'm of faculty from Padre Kosasam College of Engineering. This is an idea which came to my mind, particularly when Mr. Milind Anvikar was speaking. He mentioned that there was when they get freshers, the numbers are very large. They take 100 people, in order to hire 10 people, and that was the point he made. And he said that they started this thing of conducting boot camps for the students, and then at the end of the boot camp, hiring the students which were good. So the idea which I had is, why don't we combine the boot camp with the internship program, wherein the students are given a chance to do experiential learning, like how ma'am said, it's very good. And at the end of that internship, you can judge the student based on their skills and so on, and hire the person. So right now the problem we face is we have very few big companies which take our students for internship. If the internship could be carried out in the colleges as part of experiential learning with the skills which you require, this is especially for ODL and PSL, which are our big places for our students. So if the bootcamp idea and internship could be combined to make the students more hireable as freshers. And what are your thoughts on this?
Yes, I think we're already doing this, and as also mentioned that one of the proposal to all the colleges, including yours, was that rather than sending students for internship, we will come to the colleges. It's just not one company. As a group of companies will come, we'll run different workshops, because that you're with the talent, and then you can also use that as a selection process, and probably invest in them much earlier. So again, the thought process was, can we get the companies? One of the point is, I will invest, as a company, will invest in the students for the next 2 years. But will I get those students to work for me after they pass out? Right? That's something you're not able to commit, because this is a Goan scenario, because your priorities is to place students in Infosys, Wipros and the bigger companies, right? So this is a challenge in the Goan ecosystem. You're expecting that's a challenge even with the MOUs that we're signing, because it's many times one ways, you're expecting all help from the local ecosystem, but your priorities are to invite bigger players down to Goa and get the students placed there, because that's where you feel the placement scenario and getting the prestige. So this is a practical challenge, right? So this has to change. So if we can have students saying that you are guaranteed a job, while you are studying or after you pass out, you have to serve 2 years in Goa. What will happen is the ecosystem will also do well, and that could happen when you're doing engineering, or it could be post that. Your ecosystem will also help, and then probably people can go out, or you'll have more people coming in. So this has to also happen. It cannot be one way, and I think we're more than happy to participate. So I think this has been a conscious effort in the last 2 years, trying to see how do we build ecosystem. So what we've done is not the IT companies getting them together, getting the government on board, getting the academia on board. So I think with all of them, we tried to make sure that it's one form, and then we have started a student chapter as well. So the entire community is together, because they are the future, right? And that's where we are seeing, how do we basically talk of an ecosystem that we can be proud of, that this is what we've done in Goa. So hopefully, I think that will address, and you will be happy with what happens in the next couple of years' time.
Right. Okay. 2 quick questions here, and then I'll come to Chitra over
there. My name is Sandeep Ganorkar from KDK College of Engineering. You just talk about the communication skill and soft skills are the important aspect. But I witnessed from so many years that the students who are not good in communication skill getting selected in campus and recruited and joining. So my question is, how would you justify this, and is not it is a problem?
So I think, and I have personally hired candidates who had tremendous difficulty in communicating or articulating viewpoint, but were exceptionally good technically and in programming, and then we bring those missing pieces and we work with them to develop that. So I think the point was that for a longer term success, and many times, by the way, even as an entry barrier, it is important to have communication skills to be able to put forth your viewpoint. So you may have certain cases where people are hired because there is, the big companies hire everybody who can show up for the campus placement because the need is so much. Or in some cases, people genuinely look beyond the communication difficulty, look at the technical prowess of the individual and hire them. So those may be anecdotal, but by and large, for the long-term success of the individual, it is an important skill is what I was trying to make a point. And it's more of not, I don't want to keep it as a limiting factor in keeping people out as much as encouraging the building of that skill. Yeah.
Sir, Ravindra Jogekar from Priyadarshini Jail College of Engineering, Nagpur. My question is, some brilliant students, those who are working it out and they are brilliant in the languages, but not in the academic. So according to that, the marks, internal marks are very less for that students. So is there any type of backdoor entries from where you can get it accommodate in the industry as such? Because you are having a strategy that 60% is important, required for 10th standard, 12th standard, and the remaining semesters. But somehow they are lagging to it. So is there any point?
I think, yeah, so that is there with many big companies as a filtering criteria. But if somebody has a GitHub, like Karthik said, right, if I have a GitHub account, I have a Hacker Earth account of how many problems I've solved in high complexity and how many points I've earned. And Hacker Earth is just one example, but there are many such competition websites. With those two things, you can you don't need a backdoor entry. You'll get a red carpet welcome in any product company. You may not get in maybe with some of the bureaucracy of the big services giants, but maybe you don't want to go there anymore, right? If those are their criteria, they are outdated. Okay, I won't say my company's name here, but the point is, it's not a backdoor entry. But you can't have either that and I don't have this as well as that, then you're a problem. But if you have a GitHub, you have a top scores in all these coding competitions, that's your resume. Your degree and GPA may not matter. Now, will you get admission in IIT Bombay for doing a PhD on that? Maybe not, right? Because there is a process for that. But will you get entry into the next startup, hot startup in Bangalore or Pune or Goa? Yes, you will. Front door entry. Right.
Okay, my question was already mentioned by Venkatesh Raman, and I did not hear any answer from any of you. So I would like to again ask the same thing. That is, basically the 7th semester, from day 1 onwards, the placement schedule starts. And from that time onwards, the students don't come to class at all in a regular fashion. So the whole semester goes for the placement. And if they get placed, they are happy, and so they don't come for class. If they are not placed, then they are preparing for placement, so they don't come to class. So it essentially is boils down to a 3-year course, and according to you, first year they learn physics, chemistry, and all other things. So it boils down to 2-year course. So where are we? So why can't, if this forum cannot solve that, which other forum would solve? I don't know, because from the college side, they say that if we are not doing that, rest of the colleges would all get their students placed and we would be at a disadvantage. And the same thing I'm hearing from the industry also. If we are not going and hiring, all other companies would go and hire and we would lose out getting good students. So which is that higher level body that can tell that no one could go and meddle that 7th semester education? If you are interested in students getting good education and learning, but the very industry is meddling with that, and they are in fact, they are trying to tell that whatever you are teaching in 7th semester is utterly useless.
Yeah, I have a mic. So that's a very valid point, and it was really getting bad till a point that industry HRs came together and said we shall not go before this semester. But I feel there is both parties can really control that. One is training and placement officers of academic institutes they should realize that their talent is in demand. They have an upper hand and they should wield that negotiation weapon that they have and say, we will not let our students come for. For instance, an IIT says, I will not let any company come in before the 5th. But even IITs don't say that. Even IITs are not saying that today. If an IIT says, I shall not let any placement come before the end of 7th semester, 8th semester, companies will just have to fall in line. They have no choice. Similarly, companies, of course, I do agree, companies need to come together to an agreement saying that we shall not go before such a day and we'll follow this process and let's decide who goes first and other things. I think it lies, both parties can.
So I just want to add at least some of the experience I've had with my company, right? So we are not really that great we don't pay that much compared to many other companies. So in most colleges, we are day 3, right? And we don't get anybody, absolutely nobody, right? I think the colleges have a lot of control over this, right? It's basically saying that it's the college who decides which day we get to go and pick students, right? So, and they look at this and say, your CTC is this much, you can only come on day 4 or day 5, right? And whereas a company that gives one guy a job in the US, takes them directly to the US and gives them $1 million, will get day 0. What the hell is day 0? That's day 1, right? But they get day 0, right? Yeah, -1, right? So I think the colleges have a lot more control if they basically can try, right? So
UIC or AICT put in a top-down and
TPOs of, correct. I think TPO. Yeah, I think. Yeah, NASCOM and AICT or something at that level need to come together and say.
So again, Venki has been playing the role of holding up at the university end. Being in a university, I would like to play the role of reassuring the companies that, look, we don't really, I mean, we have to support you as well. I think universities could also say that, look, if you don't perform in the 8th semester, we are just going to fail you. Why don't universities take that stand? IITs don't take it, and I'm not really proud of it, but I think IITs and universities could take that stand. You don't work in the 8th semester, you are failed. Forget whether you get a job or not. I think it's not that we have no levers to push. Okay.
Not that, but our management or everybody thinks that ultimately the student is coming for a job. So they have already gotten it. So why are you unnecessarily? In fact,
yeah, so this is, I think, a debate that can go on forever. Yeah.
Okay, I think
just to say that, I think, see, ultimately, one of the key objectives for you to place the students, right? So you're getting that done. So I think one of the other debate would be, whether you want to probably relook at the number of subjects we have in these courses, And I think it's time probably we have to relook at, how much of hands-on sessions we're going to have. So maybe the last 1 year or so is, full-fledged hands-on session with limited number of sessions. So that's a thought. Maybe the other bodies could think about it. But I think if you have that as a concern, that has to come on a different platform as to how we structure the courses, at what point of time we're going to say industry ready. But if you're going to get the industry to come and participate into it, then we will have to probably take all inputs, and the inputs from industry will be how do we get what we want. So it's going to start customizing. So I think the focus from the academia should be, as as Venki mentioned, is, or you all have more control. You all should work out how you're going to train the students to be able to be the ones who can learn and pick up anything that they want. I think it's about the entire focus ends up being making them industry ready. So I think that is a separate debate again, whether that's the right thing or a wrong thing. And if you're going to have that as a debate, then I think we cannot say that this is a problem. This is probably one of the points that needs to be addressed in that entire requirements of yours.
So,
last 2 questions, and remember, we are cutting into lunch right now.
I know that. So probably
because the next session is going to start on time.
The discussion has started with expectation from academia to industry, and I think root or the rot, whichever we want to pronounce it, lies somewhere else. 30 years ago, 35 years ago, when I started my job, at some social gathering, some person come and ask to my cousin brother, did you get a job? Are you still a teacher? And I think that still holds true even for CS students. Last 8 years, I had taught about 800 to 1,000 students. And almost at the end of semester, I do ask, how many of you want to become a teacher? Probably one hand gets raised out of, I think, 1,000 students. I haven't got 3 hands saying we want to become a teacher. How do we hire the teacher? Who get the lowest agreed? I'm talking about the colleges, the tier 2, tier 3 level. I'm not talking at IITs, where people aspire to go there. Other colleges, if I don't get a job, I become a teacher. Why doing PG? If I couldn't get a job, after doing a PG, I'll become a teacher. So unless you address that problem, the root of the problem, if you're not fixing academia, that you don't want to, nobody wants to become a teacher, what do you expect a student to be produced? So I think root or the rot, you're coming.
No, I think that's a very good point. So this is just believe it or not, my manager and I, we had this exact same conversation last week on Wednesday or something like that. So if you look so I did my graduate studies in the US, and so one thing that we noticed there is that the really good people are teachers, right? And they may have a consultancy in a company, they may start a company, they'll do all the stuff, but they're always a professor at some university, and then their second job is basically, they run a consultancy, they have a startup, they have some incubation, all of that stuff. I think that's very important, right? And I know this from just anecdotally as well. Like for instance, in the military, for instance, the really best strategists, they become the teachers for the next generation, right? And so on. That's how you build. Completely agree that that's what we need, right? Absolutely the best people need to go into teaching. Maybe not teaching right away, but at some point in time, maybe let's say when they realize their midlife stuff, you have to transition, because that the next generation is really key, right? I don't know how to make that happen, but that's somewhere that incentive is lacking here. I agree.
Just to add only one single line to this, I think the grass on the other side is always greener. A lot of people from the industry aspire to go into teaching at some point.
So I have only one observation. Education institution should concentrate on carpentry, not on tools. This is the primary thing. The second one, it is lunch time, there should be some fun. When the industries are in boom, they used to tell all your students are amazingly great. When the industry is not in boom, NASCOM will speak. Employability problem. So there should be some line. And the next point, there is a difference between terrorists and methodologists. With the terrorists, we can negotiate. With the methodologists, we cannot negotiate. We academicians are methodologists.
So wow, with that kind of thing, maybe you get a question here. Yes. Now that's communication skill, right?
No, I'm undergrad student in my final year, so I'm youngest among everyone here. Okay. Okay, fine. Okay. Fine, sorry. I didn't know this. Okay. So whenever you're designing your MOUs, whenever you're signing, the college is signing an MOU with a company, students are never asked what they want, okay? Now, as I see, students are actually not connected with college. College and students are two different entities, and that's why companies are starting campus ambassador program so that they can actually target students directly, okay? So there is actually no relation. When you're signing MOU with a college, college is promising you by making it compulsory, if you don't attend, your attendance is gone. So it's a threat. Okay, so I have to attend this interview, I have to attend this conference so that I can get that extra bit of attendance. If I don't get, I am not allowed to write exam. Okay, so this kind of a threat, you're literally blackmailed in sitting in any of your conferences, any of your interviews. So these are my observations. Another thing is, it's quite disappointing, okay, that one exam in Indians' engineering life, that is JEE, defines the whole career that you're going to have. Okay, because I have started freelancing from second year, and my third year, I'm in final year right now. Third year, I earned a good amount of money, which was 4 times the average package of my college as a student. And I had to hide this fact by telling that I'm not well, that's why I'm not attending the classes. I made the fake certificates and all those things, because that's how it works. Because systems won't actually allow an enabler, the doer, to actually go out and do stuff.
And also the thing is, this thing, whatever I'm doing extra, won't actually come in front of you. Okay, it won't, because college won't allow that. Okay, so the thing is, I would still sit for 3.5 LPA package, though my worth is like 12 or 15 or 20 LPA. Another thing is, just one more part, is that recently, according to the research what I have done, is that every single company has two set of packages. One is for IITians and one is for non-IITians. Okay, so even if I work hard extremely in my 4 years, I did some blunder in my 12th grade where I didn't know where I have to go. But I worked my ass off for 4 years, okay? And that's not been noted at all. Still, I go and sit for Microsoft interview, and IITian for the same role is going to get 45 LPA, and I'm going to get 22 LPA. And that's really disappointing. Okay, though we are going for the same role. And maybe I would have acquired much more skill working in the field than that IITian guy. Okay, being from a lower tier college and stood up for myself and did something for me. How are you going to solve this problem? Don't you feel that hypocrisy lies in the industry where you are just putting a slab? Okay, there is nowhere I can actually enter.
Yeah. Yeah.
From their past experience, they are saying that in the past the crowd was not good, and even they stopped going to those colleges.
Sure. So very quickly, thanks for raising this. I think the part about the first part, students and universities having different incentives, the campus ambassador program, as you already put it, is trying to address that. Companies recognize it. About your IIT JEE comment, right? So I don't think that is actually going to be true anymore. It used to be in India that 12th science you screw up and you're kind of sidelined. I didn't go to I didn't get in IIT JEE. I didn't get into GATE also through GATE. It didn't stop me from rising. I think it's even more open now. Thirdly, you should, if you're doing what you're doing, then you don't actually need to sit for those. You have an entrepreneurial path ahead of you, or you can talk to me outside. I'm looking for smart people like, this is not a recruitment. But I think the broader point you raised and Karthik mentioned about faculty earlier is that I have heard this story that people, really smart students, are hiding from the fact there was a threat of expulsion by a South Goa engineering college against a student who was actually building products while he was studying. He was not missing out on any exams, or he was not shying away. Yeah.
You are not supposed to work anywhere full time.
Yes.
According to the rule of AVL-Tree or BTU or I don't know.
So I think that this whole entrepreneurial path should be freed up for both faculty and students. And this archaic rule needs to be broken. What we can do is we have the ACM leadership here, we have IIT and senior faculty leadership here, and we have industry leadership. Hopefully some of us can go back and influence the policy around this on both faculty and student to create a more innovation-oriented ecosystem.
Great,
so,
thank
yeah.
you.
And maybe add credits for some things like what you're doing so that it goes into the assessment system where you're actually recognized for what you do. I think that is...
Actually, what he's saying is right. They are not even asking for credit. They just say, don't expel us for doing this, which is what the threats are.
We are in jail. We are in jail, basically.
Yeah.
We don't have any negotiation. We can even talk to a company. Probably if I drop you an email, I think it won't be even noted from your side because I'm a student. You dropped it. I don't
So this goes back to the same comment about the US universities, right? I mean, we all use Google now, but imagine what it would be like if Stanford said that they should not start a company, right? And I think that's the fundamental thing. I don't know how we probably should address this in some way. I don't know what the forum is and what the mechanism is, but absolutely faculty must be allowed to have, their own companies or work and part-time, whatever it is. And the same thing applies to students as well. I don't see any reason why the two of them should be completely decoupled that way, right?
I hired interns in my last semester in my company, which was registered in someone else's name. And my college is asking me an internship certificate from other companies because I can't go. How ridiculous that sounds, okay? Like I am building a full-fledged product right now. And my college is asking get a certificate from other companies because this is something of your own.
Yeah. So, thank you. Not only thought-provoking, but provocative. So I think there is a lot for us to take back. Venki, you want to do just a 1 minute thing? Okay.
Everybody knows what has happened and.
So, okay. What that means is that we've come to the end, but not before we give our panelists a token of our appreciation memento. So let's do that. Venki, I think, has got his, so you get only once.
Yeah. Thanks to all the panelists for being really sporting and very, very, very good. And thanks to the audience for having so many questions. And it was fairly interactive, much more. They were initially worried, how will we spend 1.5 hours? And I told her, don't worry, we have a great audience. Yes. And
Professor Madhavan Mukund, and he's at the Chennai Mathematical Institute, and he's going to talk about assessing at scale, design and analysis of algorithms. Madhavan.
Okay. Yeah. Okay, so this is supposed to be vaguely part 2 of Venkatesh Raman's talk yesterday on what happened? On teaching algorithms, except it got split into 2 days. But anyway, there is no direct connection between the 2 parts. So coordinating for almost 17 years now. And more recently, for the last 4 or 5 years, there's been this NPTEL course where the typical enrollment, as you can see, is in tens of thousands, and the typical exam taking number is over 1,000. And so one has to really think in terms of some mass method of doing this. So without going into any technicalities, what everybody who teaches something would like to know at the end is whether the student has understood what they've been taught and whether they can apply it to a new problem. So what was hotly debated as problem-solving skills in the previous panel discussion. Right? So these are the 2 things, and the question is, can you actually measure this in what is essentially a mass way? Right? So there is a challenge of the scale. One is that it's clear that one cannot manually read through 1,020, 200 papers and assess them as you would if you had a small class of even 100, or a much smaller class like in CMI of 30 or something like that. So I should tell you that, you know, this number that I mentioned, right, like 1,200 in one run is probably, it'll take me 12 years to teach that many students in CMI. So every time I teach an NPTEL course, I add like 1 decade to my teaching career in terms of students. And it's 7,000 for Python. So the question really is, how do you measure something which is inherently the ability of the student to generate an answer? See, because that's very hard. So how do you, so problem solving as a creative task, you set them a problem and you want them to show that they can solve it, right? How do you measure that in an automated way? Now, I don't claim to have a foolproof solution, but I'll just tell you what I try to do. So first, let's get where we are starting from. Most of the students who take this course, especially so I'll start with the NPTEL part and I'll come to the Olympiad part at the end. So the NPTEL course is mostly taken by students from the so-called Tier 2 engineering colleges. So it's not designed for IIT students. And so in some sense, the expectation of the students in terms of evaluation should match with what they are exposed to at their university exams. Now, most university exams, as we know, are typically set centrally in an affiliated system. Very few colleges actually have an effective autonomous thing. And this is a random sample of questions. And I can tell you that I sampled this set of questions from 3 different universities, and they're roughly the same. Okay, one in Kerala, one in Karnataka, one in Tamil Nadu. So it doesn't change much. These questions are there in every algorithm exam in every semester, every year. Right? And now the question is, are these questions asking anything? And if so, can we ask similar things in the spirit of what these questions are asking, but in an objective, easy to evaluate format? Right? So just to run through, because I will specifically do these 4 examples. So the first one is something about understanding that the student has understood what asymptotic complexity means. So what Venkatesh Raman mentioned yesterday, that at the end of the course, somebody said, except for big O, they know everything. Right? So this should not be the case. Right? They should know big O right at the beginning. Okay, the other thing is comparing sorting algorithms and talking about, so what is best case, average case, worst case? I mean, do they really understand what it means? The third thing is talking about a specific algorithm, in this case, minimum cost spanning tree, Prim's algorithm. Can they understand what it's doing and why it's doing what it's doing? And the fourth thing is about a data structure, right? How to maintain a heap property. So, to go one by one. So this is my take on asymptotic complexity. So these are all actual questions from my March 2019 NPTEL exam. Right, so the question that I ask is that suppose somebody claims that they have an O n squared log n solution for a particular problem. What does it mean? Does it mean that for every k it will require that much? Does it mean for every k there's one instance that will require so much? Does it mean for every k every instance will be solved in so much? So basically just questioning whether the student understands what it means at all to make a claim like this. So is it lower bound? Is it an upper bound? Okay, is it a guarantee? Is it a promise? What is it? Right? So I think that this question, in my opinion, is as effective or more effective than asking write short notes on asymptotic complexity. And it's of course easy to grade because you can select A, B, C, or D, and one of them is right and the other 3 are hopefully wrong. Okay, so basically the question is that people seem to believe that if I give you a guarantee, an upper bound guarantee, it's actually a lower bound guarantee, that they require that much. So, and I think that is a misconception that many people have that. So if I could actually say something is O to the n to the 7, it doesn't mean that anything is actually going to take n to the 7. It just means that nothing will take more than n to the 7. So just to clarify these kind of questions, so you can frame variations on this question according to this. Right? Of course, now somebody pointed out when the first time I publicly spoke about this, that it also requires the student to parse the English because there are some subtleties about requires, can be solved, and so on. Right? So there is a linguistic component to this. And the only defense I have is that these questions are first asked in an assignment and then asked in the exam. So this is not the first time they're seeing this question. Right? So they should know the answer to this by the time they come to the exam. So here is a question about comparing sorting algorithms. So if you remember, the thing was to compare sorting algorithms based on best case, worst case, average case. So instead of doing that, I just asked them some concrete numbers, and this is related to something that Venkatesh Raman said and which I will emphasize in a minute. So instead of telling them something about n squared and n log n, I say that the CPU does so many operations. You have an array of this size. This algorithm will take hours, this algorithm will take minutes, this will take days, and so on. Right? And again, there's a question of will it necessarily take hours or will it maybe take hours? Right? So insertion sort could take several hours. Just because it's order n squared doesn't mean every input is going to require order n squared on that 10 to the 8. Right? Whereas if you have heap sort, which is guaranteed to be n log n, it will always take less than 1 second, assuming these numbers. Right? So this is again this both understanding which algorithms give you which guarantees and what these guarantees mean in practice. And the other part which is indirect in this is that there is an appreciation of what this n squared, n log n, n cubed means in terms of real time. Right? Time that actually execution takes, and this I will elaborate on. Right? So this is something which I always try to do as early as possible in any forum where I teach algorithms. Okay? So which is to explain to them what it means. Right? So if you have some number, in this case I think the number is 10 to the 10. Right? So I think in the code chef thing, Arjun Arul probably used 10 to the 8, which is a more realistic thing. So 10 to the 10 is just easier to calculate. But if you say 10 to the 10, right, then what these columns tell you is where you hit 10 to the 10 on the row. right? So if you have an n squared algorithm and you're allowed 10 to the 10, obviously your input cannot be more than 10 to the 5. 10 to the 5 is 1 lakh, right? I mean, order of 10 to the 5. Anything beyond that is going to be infeasible to calculate. So you cannot be calculating Aadhaar numbers and things like that if you have an n squared coin. Okay, so this is something which I teach upfront, so hopefully they've got the idea that there is a connection between the numbers that I provide and this n squared and log n, because I think many people, the way theoretically algorithms is presented and polynomial time is shown as efficient, I think there's a big divide. I think in real life, n log n is the only thing that is efficient. And in practice, if anything goes beyond that, then you're really struggling unless you have very small problem sets, right? If you're doing n cubed and n4, you can't do more than a few hundred things. So this is, I think, important for them to appreciate as, in addition to this theoretical part of what is efficient is polynomial time, because n to the 7 and all just doesn't cut it. Right? Now, there is a little bit of caution, which I learned the hard way. So supposing I take the previous question, right, which said insertion sort can do this, this can do this, and I just take another n squared algorithm, I say selection sort can do this, selection sort can do that, right? So superficially, it looks like a variation on this question, and unfortunately, the problem with naive selection sort is every input is a worst case. So actually, the answer changes, and this is not what I want the students to be able to know. Right? But the smart student will say, but sir, you said this, and I know that for selection sort, it will always take several hours. Whereas you're saying it could take several hours. Right? So then that semantics becomes, so you have to be a little bit careful when you set these questions, and there is no going back. Right? This has gone out to 1,200 people across the country, and if you have made a mess of it, the question has to be chucked. Right? So you just have a 39-mark question exam instead of 40-mark exam. So these are little things that, fortunately, sometimes these get caught in the assignment stage when it is not so important. But not everything is as, I mean, you have to take a little bit of care when you frame these questions, because the wording is very subtle and needs to be really thought through. And it's good to have, for example, for NPTEL, I have a couple of, usually 3 students who are TAs. If they are diligent, they usually catch ambiguities and they tell me. Those who are less diligent will just say, yes, sir, it's all okay, and then I find out the hard way. But most often they catch me when I say something sloppy like this. Okay. So now the third example there was something about explain the greedy algorithm for Prim's spanning tree. So really what we want to know is, everybody has typically in this course studies 2 greedy algorithms. So first of all, what is the difference between these 2 greedy? There is Kruskal's algorithm and there's Prim's algorithm. Are they always going to give the same answer? What is the strategy? They are both greedy, right? It's not ever kind of emphasized as to what is the difference in the output that they're going to produce. When will they produce the same output? When will they produce different outputs, right? So this is a variation of questions. So I say basically I will either ask them, so it says that, here it says that Kruskal and Prim give you 2 different answers, right? They both compute the minimum cost spanning tree, but the 2 spanning trees you get are different, right? So what can I tell you? So will the minimum cost edge in the overall graph guaranteed to belong to both trees? Are there going to be no duplicate edges? Are there going to be duplicate edges? Right? So this is really, I think, without actually asking them to execute an algorithm or memorize the fact that this is greedy or something like that, I think it requires a little bit of appreciation of what's going on. And so I hope that this is a good question to ask about this. And you can ask this about other algorithms. You can ask about Dijkstra's algorithm. What will happen? So there is a subtle difference, for example. So this is the way I put it. So you have make my trip. Right? So now, make my trip computes shortest, cheapest fares for you on all routes. Now tomorrow, one of 2 scenarios happens. Government introduces 18% GST on every leg, okay? Or government imposes 200 rupees surcharge on every leg. Which one of them will mess you up? Or will both not matter, right? So if I multiply every edge by a factor, a uniform factor, or if I add a uniform constant to every edge, will my old Dijkstra solution be the same as my new Dijkstra solution? Okay, so it turns out, of course, that if you multiply everything by 1.18, no problem. But if you add, then long paths will add that many multiples of that, whereas short paths will add fewer things. So they are not the same. So in both cases, it looks like you're adding something to the cost, but the cost, the way it's being interpreted, is going to be different. So I think these kind of questions, if you think about the algorithm carefully, you can ask questions which test their understanding. Of course, Abhiram has always pointed out, you should not spring this as a surprise. And therefore, I usually do have variations of these questions. And NPTEL also insists, to their credit, that they want a substantial overlap between the continuous assessment quiz and the final exam. There should not be a radically new, I mean, maybe like 25% questions may be of a new type, but 75% questions should reflect the questions that have been asked before. So they have been asked to think about this. That's my only defense. Okay. Okay, so the fourth question in that generic list that I had was about manipulating heaps, data structure. So of course you can ask that, right? You can say, take this heap, it's a max heap, and do delete max. What is the new heap, right? And you give out various things. So this is a very straightforward thing to ask. And if they know how to manipulate a heap, they should be able to get this. Okay, but you can do something more interesting. So you can say, you could do it in reverse. So supposing the last thing I inserted was 93, what was the heap before I inserted 93? Right? So this requires a little bit more thought. Right? Because you have to invert the operation which you have been taught, not perform it in the forward direction. And it's not the same as delete, right? So it's some random number which has been put there. So 93 is somewhere in the middle of that thing, and you want to remove it and say what would have been the heap before. So this is also testing their understanding of how the heap was built. And you can ask an even more vague question saying which of these could have been the last number which was introduced, right? So one of them is not possible, and it turns out it's not on the path from the, because you know that a heap is a tree with a fixed shape, so you know where the last thing came. So anything that is touched is on the path from that to the root. So if it's not on that path, it could not have been touched, right? So that's, so these are all variations on a theme, but you can ask questions which are, you know, what you might call calculating questions on a data structures thing. So in a similar vein, for instance, you can ask questions about search trees. So you can draw some fairly obscure, not necessarily balanced, some obscure search tree and say, so these are some random, I mean, just call them ABCD. So the values are not given. And then you just tell them, point to a node and say, in this search tree, which is the preceding node in the search order, or which is the next node in the search order. I mean, so it requires them to do a little bit of thinking. So you can ask such questions without, you know, forcing them to write things. So the whole idea is to make it easy to evaluate. So these are all multiple choice. Okay. So then we come to the more tricky part, which is this creative part, right? So it's obviously hard to ask them to design an algorithm because somebody has to then check whether that design makes sense or not. But at least you can ask them to choose a strategy, right? So everybody, I mean, in the initial thing learns the stack queue and all that, but it's very hard to find any book which has any reasonable example of a stack other than somebody might give postfix evaluation as an example of stack. So I really racked my brains, and did a lot of this thing. So this is one example. So for example, if I give you an undo in an editor, and I want to keep all undos until I save, right? Then I need to keep it in a stack because I need to undo back in the same order, right? So this is what is question. If I want to store the undos, what should I store it in? Should I store it in a queue or a stack or something, right? So this is more to do with reductions but NP completeness, but still, I mean, you give a situation. So this is asking about some hotel called Cheap and Best, which is trying to save on fire extinguishers and putting them at intersections of corridors. So what is the smallest number of fire extinguishers they need to cover all corridors? Right? So this is the question. So the question is, what is it as a graph problem? Right? Is it a spanning tree? Is it a vertex cover? Is it a independent set? Okay. So these are some ways to get them to expose their understanding of the general classes of problems that they have been taught about without asking them to write an algorithm. I mean, I cannot, as I said, evaluate an algorithm, but I can ask them to do this. So the second part, which I make use of in this NPTEL thing, is related to what Arjun said the day before yesterday, which is to use an online judge. So I use sample problems, relatively easy sample problems, okay, from competitive programming. And it helps that since I am also involved in the Olympiad, I have access to a large number of these problems, and I have some idea about where to find a problem on graph reachability or a problem on dynamic programming or something without searching too hard. So this is, if you know the answer, don't tell anybody because this assignment is due on Friday. But anyway, so it's not that. The point is that this is a problem that we used, 9 years ago in our training camp. Right? So it's a dynamic programming problem, but I'm not really asking them to be too creative. So I even tell them, You know, that this is in this week because it's from dynamic programming. And even more, I tell them, try to estimate that quantity. Right? So I tell them what is the quantity that I want you to estimate, to write a recurrence for. So I try to give as much. Some of the students write to me saying, sir, you're giving too many hints. But of course, many of the people can't solve it anyway. So this is the most controversial part of my algorithms course right now, because many students are just completely floored by this. Fortunately, it only counts for some 10 marks or something like that, I forget. But still. NPTEL has recently started a new policy where they want 40% in semester and end semester. They used to have 40% overall. But now they want 40% in the 25% and 40% in the 75%. So that means that they have to do some of these things. And the level of, the depths of incompetence are, I think, grow deeper and deeper. So this time, after 9 iterations, the 10th iteration of this course, I found that the vast number of students, and I don't know vast number, a large number of students could not execute this step. The first line of input contains 3 integers. Sir, how do we read 3 integers from the input? So they didn't know how to do that. Forget about solving the problem, right? So there is a serious problem with programming. And these are not, this is an Olympiad problem taught to school students. These are engineering students in computer science and engineering, typically, who are at least in their 3rd year, normally. Right? You would expect that they know how to write a program which can read 3 integers from the input. Forget about solving a problem. But anyway, the point is that it's very detailed, so you get all the format, but you also get this, what Arjun probably mentioned, which is that there is an indirect, going back to that table which I had about inputs and order n and all that. So it tells you that, you know, n is 5,000, h is so much, c is 10,000. So you have an idea what is the expected complexity, because you know that it has to run in some 10 to the 8 seconds, right? And then you're even given a guarantee that there are 30% inputs where you can be sloppy. You have only 500 and 10,000. So this is typically the style of Olympiad or competitive programming, that you are given a hint indirectly because you have to be given some hint. So you're not told what algorithm to solve, use for the thing, but you're typically given a hint as to what is the expected complexity of your algorithm, because the constants are, upper bounds are given to you. So I additionally give this hint which is not part of the original problem. Right? And still, of course, many of them don't solve it, but this is one way I think that one can add this generative, creative thing. Of course, one cannot solve other social problems like sharing code on WhatsApp and all this thing, right? So there's, unfortunately, our level of academic integrity is extremely poor. And so anything which is not supervised is assumed to be fake. But even with that, they're not able to solve it. So what can I say? Okay, so that is my NPTEL bit. Okay, so now switching to the other thing which is older than NPTEL, but which has a different goal in mind. So this was aimed at identifying algorithmic talent, not necessarily programming talent, algorithmic talent in school kids who have never been taught computer science formally, but they might be smart in maths or other subjects. So here the idea is that you pose a problem which is requires some computation, and which behind it has, in this particular case, it's actually a dynamic programming problem. But they require some idea to solve it efficiently, because you can always do it by brute force. But but I don't want to know how they solve it, because I cannot, again, the Olympiad numbers are smaller now, but it's still in thousands. So it's not practical to actually read all these answers. So you want an easy to evaluate format, right? So here the easy to evaluate format is that you give them 3 suitably horrendous looking inputs and say, you solve these 3 inputs. I don't want to know how you did it, right? And this is not a multiple choice question. You have to produce a number. So there's less opportunity. This is also a proctored exam. They're going to do it in exam hall with invigilation. So there's no, hopefully minimal amount of copying and all that. So they have to write an answer. So it's easy to evaluate. This was actually, until about 4 or 5 years ago, this was actually manually evaluated. We used to get bundles of papers coming to us from CBSE to CMI, and students, Arjun was one of them, used to sit and elaborately, but basically you have a sheet of numbers and you just want to check that the numbers are right. So it's really a mechanical evaluation. Anybody who has the answer key can evaluate it. Right? And the other thing is that to incentivize somebody that that they got the right answer, right? So you get 5 marks for each part, but if you get all 3 parts right, you get 5 more. So basically, if you got 1 or 2 by fluke, then you don't get the full credit, right? So it's 5 plus 5 plus an extra 5. So that has been generally working, although now we also have a programming test, and now more students are aware of programming, so there are 2 routes to go to the second round. So half the people write this and half the people write that, and I think generally the students find that this is harder than that, because in the programming thing, we ask more straightforward questions in the first round. But there are enough people who don't have a programming background in school, and enough students who try to attempt this, because especially those who are coming from a maths Olympiad or that kind of a background. So one of the difficulties in this format, okay, where you're asking a question, where you have to explain the question, is that if you want to ask a question, simple question about graphs, then if you draw the graph, any small graph is sort of easy to solve visually, right? If I say what is the longest, largest connected component in the graph, I have from 20, but you can just, or even more trivial, if I ask you, is this graph connected? Obviously, if you look at it, you can tell whether it's connected or not, right? So it's not that I can provide you a hidden input and ask you to write an algorithm. So one of the strategies there is to give graphs which are implicit. Like here it says that there are words, and the words are connected if they are their neighbors, if they are, you can change one letter and get from one word to another. So the graph is not presented to them directly, and then they're asked to find some longest path in this graph. Right? So you have to be, you are limited in the scope of problems you can ask, but you can ask, and of course some of the problems don't involve algorithms at all. They're more like combinatorial kind of reasoning problems, where there might be indirectly some kind of recursive formula that they have to compute, but not necessarily come up with a procedure. Okay, so so the main point I want to say is that it is not incompatible to have objective evaluation and test understanding. I mean, most people believe that objective exams can only test memorization or basic fact recall. Okay, and I recently found out that this is called higher order thinking skills. So, so you can use objective evaluation to so-called test higher order thinking skills. And I think when used wisely, programming contests can be arbitrarily difficult. So you have to pick and choose. So that's why you need some experience as to what level of problem is doable and is relevant to the problem that you're trying. So in this case, I said in the algorithms course for NPTEL, I deliberately choose problems which are directly connected to the subject of that week. Right? So they are not anything less, nothing more. So that they should, in principle, be able to solve it with some minimal deviation from what has been taught in class. That they cannot is a different issue, but they should be. Right? But with wise choice of problems, and there are enough problems. The other problem with programming contests is that most programming contests which are available publicly also have solutions which are available publicly. So it requires a little bit of creativity also to change the story. So it's not difficult to take a story and change it so that Google cannot find this problem. Right? So you can use, because you need test data. That's the main difficulty with programming contests. It's not enough to have a problem. You need the test cases, and you need that. So if you don't have it, so through the Olympiad, I have access to problems with test cases. But if I take a problem from somewhere else, it's not guaranteed that I have the test data to test it. So either I have to find somebody to do that, or I have to do it myself. Right? So it's convenient to reuse problems, but be careful that the problems are not already in the public domain and people have not already put solutions out there. And the last thing is through the Olympiad, that you can indirectly check some algorithmic ability through a pen and paper exam. Now, to be sure, this is not a recipe to solve all problems. Right? These are techniques born out of necessity, because I have to evaluate these students, and I have been trying to do it, but I'm not claiming that this substitutes, and certainly you would not use this kind of a mechanism if you're trying to produce, algorithms researchers. But I would claim that the bulk of the students who are coming out of engineering college, if they can understand algorithms at this level, I think they're already functioning much better than they are currently. So they don't need to be able to create new algorithms. They need to be able to appreciate and use existing algorithms in an appropriate way, in an appropriate context, and understand when one works and one other one works. Right? So, so this takes a lot of time. Right? So I do not normally put these questions out. For example, NPTEL wants these questions to be archived. I do not, simply because it is impossible for me to ask completely new questions every time. And the big danger of these kind of objective exams is that it very rapidly becomes a question bank. right? So if there is an archive of questions, I'm sure there is a question bank out there, but at least I'm not actively aiding that question bank. That's all I can say. So it takes a lot of time to come up with these questions and to keep creating new ones. I cannot claim that I create new ones every time, but with some epsilon variation, and sometimes I come up with new ones. Like this inverting the heap was a new question which was used last time. So sometimes I get a bright idea once in a while and it works. But it takes a lot of time. So it's not for the faint-hearted. But I think that if you apply your mind, of course, now this is very specific to algorithms. I cannot claim also it's a recipe for all subjects, but I think Sudarshan will talk about databases. I'll stop.
So have you considered fill in the blank type of question?
Yes, it is possible. And for instance, yeah. So the question was, can you use fill in the blanks? Very much so. I did not used to use it for algorithms much, so I have more out of inertia. I keep them in this MCQ format. But there is a corresponding course in Python, which is also kind of slightly data structures, algorithms, and all that. And there is a mixture of both, where they have to. So it's like that Olympiad thing, where you have to generate an answer and put it in. So that's also possible. Yeah.
Any other question? Yeah.
Yeah, thank you for your talk. So I was interested in the responses, if we try to look at the responses to these answers. So maybe with those, we would be able to come up with like an inventory of where all are the difficulties coming in from. I mean, what is the nature of those difficulties? Because they're very well designed questions. So maybe that would help us, like people like us, to look at what are the inherent difficulties in algorithms. Maybe that would add to the knowledge base of it.
Yeah, I agree. And in fact, the first time I gave this talk, which was about, I guess in February in Kochi, I started with that in the sense that I looked at, so NPTEL, because of this automated platform, they use this TCS, sorry, this thing is in the middle, I can't be at the mic and see you. Because they use, they use this TCS ION platform, they do get a detailed dump of all the responses. So you know not only the score, but you know that candidate answered A, B, C, A, B, 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 or whatever. So you can do that analysis. But before that, I wanted to see if there was a pattern in the answer response itself. So I saw, for example, that the overall median score was, say, something, I don't know, 50% or 51%. So is there that people are getting more on some questions? And then I found no pattern. I went through 3 such papers, and there was it was totally random. And I don't understand this, So from beginning to end of the paper, which covers from whatever, some basic O notation to NP completeness, all questions are of the same distribution. 51% get it right. And it's a different 51%, obviously. So discouraged from that. I did not delve deeper into this, but I think you're right. I have 10 courses worth of data, and I think it is worth looking at it and seeing whether there's any sense one can make out of it. Yeah.
Any other question? Yeah.
So when you're designing the options, do you take care of the usual misconceptions that students have and addressing that in those options?
Yeah, so I do try when I can think of the misconceptions. Sometimes I cannot, but sometimes I do. Like, for example, in this, like this O notation and all that, thinking about lower bounds versus upper bounds and all that, definitely that's there in the as part of the thing. But it's not always possible to do that. But yeah, so I would say, it's not 100%. Maybe 3 out of the 4 questions, options have some sense, and the 4th one might be just something I throw in because I have to make a 4th one. So, yeah. Yeah.
So you can use this. Any one last question? Okay. Well, let's thank the speaker. So our next speaker is Professor Sudarshan from IIT Bombay, and he's going to talk about X data testing and grading SQL queries. Sudarshan.
Thanks, Mukul, for leading into some of the motivation for this. I'm going to be talking about testing and grading SQL queries, which is, of course, just one corner of what all of you teach. But the principles behind this are also used by other researchers for actually evaluating programming questions. So I'll say a little bit about the more general thing later in the talk. So this work is joined with Bikash, who finished his PhD recently, earlier this year, and a number of master's students across the years. So the basic issue is this. Those of you who teach a database course knows that SQL is a rather weird language. People are, after the algorithms course, they're used to imperative programming, but SQL is very different, and getting SQL right for complex queries is not easy. The simplest SQL queries, students don't have an issue, but as things get more complex, there are problems. So, given student answers to an SQL assignment, how do you check if a particular answer is correct? You can do it manually, and I'll show some examples of issues. You can do it on sample data sets, and I'll talk about some of the issues there also. There is a related problem, which is how to check if an SQL query in an assignment. This is not a teaching thing, but in an industry, somebody has built an application, there's an SQL query, is it correct? And this is again a big problem out there. People test it on a few databases and see if it is correct and assume everything is fine. But of course, problems come up later when the decision support system or whatever gives wrong answers and could lead to problems. But we are going to focus on the student part of it. So here is this situation, manual grading, which many of us do. You read the question, you or your TA reads the question, and the TA has to spend a lot of effort saying, this thing looks okay, but is there some corner case where it will fail? Or they may find a different one, which they have no idea what it's doing, but they're not sure it is wrong. There's just a small chance that it is correct. And of course, all this takes time. So they have to make a choice, and they give some marks, and then the student, on the other hand, who did it right says the TA didn't understand what I did, it's actually correct. Of course, 90% of the time the student is wrong, it is actually wrong, but you have to put a lot of effort into convincing them that their answer is actually wrong. You have to generate a data set which gives the wrong result, essentially. Or sometimes they say that they cannot prove their thing is correct, but they say, how can you tell me it's wrong? You know, that's the same thing, prove it. And of course, if the TA makes a mistake, which could go either way, if it's a mistake favoring them, then they're very happy, and they'll say the TA is stupid. If it's a mistake against them, they'll again say TA is stupid. Okay, so you can't win. Okay, so what are the kind of errors that you see here? So here is a small example. Find the number of high-paid instructors in each department. And here is a wrong query which somebody has written. If you're familiar with relational algebra, this is selecting instructors with a high salary and then joining it with the department relation. And then for each department, it is counting how many such instructors are there. This is essentially wrong because if there is a department where there is no high-paid instructor, that department will just vanish from the result. But you probably expected that department to appear with a count of 0. And you can, in fact, do it. And the thing on the right is the correct query. And instead of a join operation, it uses an outer join operation. This is a kind of common error which people make. Okay, so this is one example where you could see that a join is there. It should have been an outer join. Now the same thing, let's take in SQL. And this is equivalent. It's a slightly different version of this query. So here, you have an same thing, department left outer join, and this is the high-paid instructors. And this one is also doing a left outer join, as you see over here, except that this blue part which was inside there has moved out a little bit. And if you are a TA, you glance at it, everything looks fine, you say it's correct. But actually it's wrong. The movement of this thing changed the semantics and this is wrong. So that would be a problem for TAs to catch. And then there are other kinds of errors. These are very simple errors, greater than becoming greater than equal to. And if you look at the one on the right, it looks different. I mean, compare these two, okay? So let's say that this one, the correct version was greater, so this part is okay. But if you look here, this one says count instructor ID, the other one says count distinct instructor ID. And somebody may think that that is wrong and not give marks for it. But in fact, both are correct. If you understand the constraints in there, ID is unique and so on, both will give the same answer. Okay, so far so good. So reading it is difficult. So why don't you just run it on test data sets? The problem is, how many test data sets do you run it on? Typically, you have one or more sample relations which you run it on. But the TAs are always worrying, are these data sets sufficient? Maybe there is a subtle error which is not caught on this data set, but a different data set could catch it. So, okay, fine, you put in some effort and you create one more data set. Am I done? Am I missing some other error which a different data set would have caught? And so that's the problem here. The particular query is passing all the data sets, but you're not sure. And of course, on the other side, the students, in this case, if a data set showed that their query is giving a wrong answer, there is proof. Okay, but so students are not going to be unhappy, but they may be unreasonably happy because wrong query got marked correct because there weren't enough data sets to catch it. Okay, so that's basically the scope of the problem. And we have been developing the Xdata system now for almost 10 years now, starting with the earliest work on this problem. So essentially how we do this is the instructor writes one or more correct queries for each assignment. The assignment is written in English, a description, and then the answers. Those are fed to the Xdata system, and it generates multiple data sets which are designed to catch different errors. So then what we do is, for each student query, we run the student query and the instructor query on each of those data sets. And if the results match on all the data sets, we declare that the query is probably correct. This is not a proof of correctness. But if our data set generation is good, in almost all cases, if it passes all the data sets, it would be correct. This is going to be much better than manually generated or a few data sets being used. Okay, what happens if there is some case where the query does not give the right result? Supposing you give 0 marks to the student for that. And by the way, this is standard in most programming tests. Right? If you fail one input even, you get 0. Because some people may say, well, let's try it on 10 inputs, and if it passes 8 inputs, you get 8 on 10. Right? But that may not be the right thing to do. So it may be that there was a very small error in the program, and it failed 9 out of 10 data sets because of that small error. It just tweaked one small thing, it would have worked. So the student actually understood the logic, did everything almost right. Okay, so we're going to come back in the second half of the talk on how to give partial marks. And this is very important, otherwise students get disappointed that they are losing marks for a very small error. They are not happy. Okay. So now we are talking of errors. So what kind of errors are we targeting? So we need to have this thing, and the term mutation is basically a way of thinking about errors. It's a syntactic variation. May or may not be an error, but it's a syntactic variation. In our previous examples, using a join instead of auto join is one such. And then we say that a data set kills a mutant of a particular query queue if their outputs differ. And we have a notion of a mutation space, a set of mutations that we consider. Now, any system will have to look at some finite set. There may be errors outside of this set which the system does not explicitly target. It may happen that the data sets generated will catch errors outside of this set, but that cannot be guaranteed. We can, of course, check it on real student programs and see how well it does, which we have done. Okay, so what is the basic idea in catching these errors? And this, so here you have a very simple case, an inner join versus an outer join. And what would catch it? Well, you need a data set where the relation on this side has a particular tuple. On this side, in this case, we have chosen to leave it empty. So if you look at the join condition, r dot a equal to s dot b, there is no record in S which will match this. And this is a classic case where the inner and outer join don't match. So this is the sort of thing which one has to generate. Now, by the way, when we are talking of exams, it's actually interesting sometimes to give a query or give a pair of queries and say give an input where these two will give different results. Of course, grading it requires a little more effort. You have to actually run it on the student's input, but you can constrain it in various ways to generate interesting questions in exams which go the other way. Okay. So of course, this is a very trivial example, but this is the starting point. Real SQL queries are much more complex, and the number of mutations possible is very large. So I'm not going to list the SQL features we cover, but we do cover standard SQL queries, including with subqueries. And in terms of the mutation space that we consider, for example, join type mutations. Inner join goes to left outer join, right outer join, full outer join. And it turns out that it's very important to consider all possible join orders. So it's not enough to take the initial query that you have, but to take equivalent queries and mutations on the equivalent queries, because the student you may have written this, the student may have written an equivalent query with a different join order, and a particular mutation is not possible on this query syntactically, but it's possible on the other query. But you should catch it still. So that's something which our system handles. Then there are comparison operator mutations. These are the most obvious ones. Less than goes to less than or equal to. Aggregate, instead of min, somebody used max, or sum versus count, and so on. Distinct is another important thing. The example we saw before, that was at the top level of a query, but it can also happen inside of an aggregate. And this is another very common situation. If you're familiar with the group by clause, someone may have an extra attribute or may have omitted some attributes there. And this actually is interesting. I'll come back to it a little bit later in the talk. Yeah, so sorry, this part is repeated, but then we have subqueries, mutations of subqueries, exist versus not exist, in versus not in, and so on. Missing subquery, mutation inside subqueries, and so on. So this is just to give an idea that our system does consider a pretty wide range of things. If you consider only a few, you're going to miss things. Now, when you generate data sets, there are some challenges. The first thing is when we are considering a particular mutation, we have to create a data set where that particular thing will result in a difference. But this is, let's say this is the one we are targeting. It's not the whole query. The query's result is here. So not only do you have to generate data which will create a difference between this and this, but you have to generate data for this thing which ensures that the difference will propagate out. So that's kind of the basic intuition of how we create a data set. Yeah. So now, how do we actually go and create the data sets? Our first attempt was to take some sample data and try to get a subset of it which gives the right thing. But then we realized, any query which we write has to sort of match that data set, and it constrains us greatly. And we can't give guarantees reasonably that it will work. So instead, what we did is, following upon other earlier work, we create a bunch of constraints on variables. And if you think of these variables, each relation, can think of it as an array. And in that array, each cell in that array is a variable. So we want to create a relation, and we have constraints on the values in these cells such that some property will hold. For example, you have an array for relation R, an array for relation S. Primary key will indicate that you cannot have duplicates in this. Foreign key will mean for everything here, there must be a corresponding thing there. So you can actually create assertions like this in a suitable language. And then we invoke a solver, constraint solver, to solve this. What kind of constraint solvers? There are these things called SMT, or satisfiability modulo theory, which basically handle typically integers, rationals, and so on. And there are extensions. We had to actually build one for strings ourselves, but more recently SMT solvers have started supporting strings better, so we can switch over to those. So essentially we create these constraints. We used a particular solver called CVC3, and we have now switched to another one called Z3, which is now the industry standard from Microsoft. Okay, so that's basically how we go about doing it. Now, of course, there's a lot of devil in the detail. A PhD and many MTech projects worth of devils in the detail. So I'm not going to bore you with all that. That's multiple other talks. So let's assume that we have figured out how to do this and see what we can do after that. So as an instructor, you don't care about how I did it. You care about, is this effective? Is it going to make my life better? And so that's the next step. Is this correction using X data? How is it compared to using a few fixed data sets versus using TAs? And we had before X data was used, TAs had already corrected previous year's assignments, so we could go back and check it. So that's what we used. Now, false positives, of course, can occur because we are creating some number of data sets. Are we missing some errors? And I'll come back to that results for that. And one way of avoiding false positives is to check if two queries are the same somehow. And one of the intuitions we had is, let's look at the query plan which the optimizer generates. Even if you give two different queries, if the optimal plan is unique, they should be the same. But it didn't work at all for various reasons, such as less than versus less than 10 versus less than or equal to 9, for example. So a lot of issues like that. This just didn't work. Okay, so how did all this fare? So here is a bunch of queries from an actual assignment. And this is the number of queries which were found to be erroneous by various techniques. Xdata is the blue one. We have this university data set, a small and a large one, which we also used on these. And if you look across the board, Xdata basically dominates the others. In some cases, it's the same as some of the others. In some cases, it dominates. And as you go further to the right, you will see that the queries are more complex as you go. So the ones which have more errors are obviously the more complex queries. These are very, very simple queries. Hardly anybody had an error. And you will see that it's doing not only better than the data sets, but it may be doing better than the TAs also. TAs missed many errors. So that we were happy with that. We can catch the errors. So when we did this, we used it, then we soon realized that how many marks should we give to those students who had erroneous queries. And that motivated the second part of the talk. But before that, I want to mention that there's been other related work. Query-independent data generation was some of the earliest work. Just generate data sets satisfying the integrity constraint and run queries. No guarantees that you'll catch errors. Given a query and a result, create input that matches the output. That was the succeeding work. Again, no guarantees of catching errors. There's some other work on generating results of a certain cardinality. And then the part from here, data generation by creating constraints to ensure that a query does not have an empty result. So that was a body of work here. And then there was some follow-up work which tried to catch errors, but it is nowhere near as exhaustive as what we did. So this is all earlier work. More recently, in the last couple of years, there has been work on trying to prove equivalence or non-equivalence of two queries by using theorem provers, basically. And so if it's not equivalent, they generate a counterexample. If it is equivalent, they try to prove it is equivalent by a certain proof. Because there may be some cases where if they're not able to prove it is equivalent, they're not able to prove it is not equivalent either. So there could be a gap there. This work is quite interesting, but it turns out A, it is slow. B, if you try to model all the complexity of SQL, like null values and so on, these things don't work as of now. Maybe in the future it will, but as of now, you can't even use these techniques. And then some other work. So these are the corresponding papers. If you view the talk later, you can follow up if you're interested. Okay, so now let's move to the second part, automated grading. So this part we already saw, the part on the top. You generate different data sets, we run it. Now do all the results match? If yes, that's fine, we saw this much. Now, if some result doesn't match, what do you do? Always 0 marks? As I said, students are unhappy. Number of matching data sets. I told you earlier that a small error might result in a large number of failed data sets. But there's another problem with this. The sort of data sets that we generate to differentiate between a correct and a wrong query often result in an empty data set for the correct query. A wrong query would give a non-empty data set. So now you can guess what a smart student would do, right? Write a query which always gives the empty result. And they'll get maybe 40% of the marks. Great, without learning anything. Okay, so you can't do that. So that's a problem. So they're either going to be unhappy or very happy unreasonably. By the way, this is interesting. There are companies which recruit in all the colleges, you know that. They conduct programming tests. There's one particular company where they gave a hard problem. And apparently some students, and they had one sample data set with the output. So the students just put a bunch of print statements to print that result out. And this company included that in their test case. And all these students got marks. The people who seriously tried it, they failed because it was quite a hard problem. And those people got called for the interview. These guys didn't. Okay? So, I mean, this is a stupid thing which company shouldn't have done, but it happens. Okay. So what we want to do is give partial marks based on how close it is. Now, how do we do this? The first obvious thing that you might think is, hey, model the query as a tree, the student query and the instructor's query. And there's a standard notion of tree edits. And so find the edit distance. There are good algorithms for this. Find the edit distance, and that would be a measure of how close you were. But that's quite unfair. So take these two queries. They're both correct queries. The blue parts are different. So in this case, it says text.course ID. In this case, it takes course.course ID. But if you look here, there's a condition which ensures that those two are always the same. So you could use either one. It doesn't matter. Take this one, a year greater than 2010. This says year greater than or equal to 2011. Obviously, they are the same. So you really don't want to penalize such things. That will be unfair to the students. So what do we do? Okay. So we are going to look at how to canonicalize it. So that's the next part of the talk, is how to canonicalize this. So what do we do for canonicalization? I'll show you a few examples. With clauses, if you're familiar with it, these are like subroutines, are expanded out, inlined essentially. So that if somebody has used a subroutine, someone has not, it doesn't matter, it will get inlined. Then certain constructs which can be replaced by equivalent constructs are replaced. Not A less than B, for example, becomes A greater than or equal to B, and similar ones. Then there are some interesting ones. If I have a sequence like this, A equal to B, B equal to C, C equal to D, query optimizers have long recognized that this kind of a thing, where a bunch of variables are all equal to each other, form an equivalence class, they have to handle certain things like cardinality estimation, especially for that. In our case, what happens is, anywhere above the expression which does this, you could have used A or B or C or D, it doesn't matter. In the previous example, we saw that. So the canonicalization essentially replaces all occurrences above by one of these, say the lexicographically least of these, so that it becomes unique. You can also remove redundant joins. You can convert outer joins to inner joins under a variety of conditions. So there are many things one can do, and we do all of those. These are techniques which have been proposed for query optimization, but often not used because it doesn't help that much, but for us it's important. Then there are some other interesting things, right? If you did this, right? There was a query which said order by student ID, student name. And somebody else wrote order by student ID. Now, you could figure out that they are equivalent because the ID is unique. So the extra thing doesn't cost anything. It doesn't hurt. Maybe you could say the student was doing it unnecessarily, but it's not wrong. Similarly, for group by clauses, you could say the same thing, but it's actually more interesting here. This one said group by student ID, student name. This one said group by student ID, student department name. Both are fine, and they're both equal to the original one. And there are somewhat more complex examples. So we can handle all those. There's also some limit to the kind of canonicalizations we can do. For example, removing nested subqueries, it's called decorrelation. And for simple queries, we do it, but for more complex queries, it gets a little messy. And so what do we do in such cases where there's a different correct query, but we are not able to canonicalize both to the same thing? So in this case, we just allow the instructor to specify multiple correct queries. So the instructor sees that here's this other query which looks very different from mine, but it is correct. I add it to the pot. And so you can compare with any of those. Okay, so that is canonicalization. Now canonicalization can be now used to compute the edit distance. So we first canonicalize student query, instructor query, then find edit distance. And we were quite happy with this till somebody asked us, what guarantee can you give with this? can you guarantee that you have some unique minimal thing over here? What if your canonicalization actually makes things worse? And in fact, that could happen. It can cause divergence where the original one was actually closer. So here's an example. This one is the instructor query. There is a join. And this one is a student query, which also has a join. So the only difference, if you see between these two, is a particular where clause here is missing over here. Okay. Now, in this case, there is a foreign key dependency and so on, which can let you infer that for this query, a join is redundant. We just keep the student and remove the takes. Okay. So there's some assumptions here. Student has taken at least one course, blah, blah. So we can actually remove the join. If we do that, you get this. So that canonicalization is actually useful in some cases. In this case, it does this. And now visually you can see that this is further away from there than this was. So canonicalization has actually given worse results than not doing it. So what do we do? So can we have a technique which actually gives some sort of guarantees? And the answer is to find a minimal edit sequence such that after doing these edits, the student query becomes equivalent to the instructor query. And now the partial marking is defined on how long this edit sequence is. If you can do it in one edit, then you get almost all the marks. If you need 10 edits, you're going to lose more marks. How big is the edit? It can be defined in terms of the tree structure. I won't get into the details, but you could do this. Edits include insertion, deletion of subtrees, replacement, movement of subtrees, and so on. So there's a space of edits, each with its own weight. Now there are two challenges here. First, if I edit a query to make, my goal is to make it equivalent, but how do I check these two queries are equivalent? So there are, as I said, techniques using theorem provers to check this, but they're expensive. Just given a pair of queries, they take time, and B, they don't model SQL null values and so on properly. So we can't do that. And so we use canonicalization to approximate this. The second problem is how to find a minimal edit path. So I'll address both these. So to test for equivalence, what we do is take the two queries, canonicalize. If they're the same after canonicalization, then we say they're equivalent. Of course, there may be things which don't canonicalize, even though they are equivalent. And here we assume instructors are given further alternatives. The other alternative, equivalence checking using theorem provers, is too expensive. A third alternative, you run it both on data sets. You edit it, run it on a data set, see if it now gives the correct answer. A, it is slow, and B, similar to just running on data sets, it can have false positives. So this is what we chose. Canonicalization shows that they are identical. That's our test for equivalence. And it's fast and reasonable. Now the second problem is finding the minimal edit path. So the number of possible edits on a given query is very large. So you can assume less than 5 can be edited to any other integer. It's infinite. Of course, we don't want to do that. So the first idea is that we actually have a correct query. So we can use it to decide which edits are potentially useful and not use other edits. So this reduces the space significantly. For example, if this is the correct query, this is the student query, we see there's a difference here and a difference there, then those are the possible edits. But even with this, there are potentially lots of edits. And finding the minimal path, if you try to do it exhaustively, it blows up. It turns out that you can show it that it's basically the shortest path on a conceptual graph. As Mukund said, he gave this example with words and edits on the words, which define an implicit graph. These edits, mutations here, essentially define an implicit graph. And going from one to another is a mutation. And this graph is very large. It's not pre-created. You kind of build it as you go along. And you can do Dijkstra on this graph, which is constructed as you go along. And that works, but it's still too expensive. So we end up using a greedy heuristic. which basically considers all possible edits and consider a cost benefit, where benefit is reduction in edit distance with canonicalization, and the cost is how big that edit is. So we greedily pick the edit which gives the most benefit, keep going till the next edit basically gives no benefit. It gives the final query and you stop there. So, so that's what we use. Now here's an example of why this path choice is important. So this is the same one which we saw in a couple of slides back. And here, you could, so this was the student query, this is the correct query. The student said r dot a equal to s dot b, when they should have said r dot a equal to s dot a. So if we do a join condition edit, or selection is also wrong as per this. Okay, if we do this, this is what you get. If you do that, that is what you get. Now if you canonicalize, you will find that this one is actually equivalent to the correct query, although there is still a difference. This one is s dot a greater than 10, that one is r dot a greater than 10. But canonicalization will show that they are equivalent. Whereas this other one, you have to do one more edit to actually make it right. So finding the shortest path in this case does the right thing. And the greedy thing actually works fine on this. Okay, so far so good. We have a way of computing partial marks. But you as a teacher say, hey, you are just cooking up something here. You know, why should I believe that this is a reasonable way of giving partial marks? And this is actually a bit of a problem. How do we decide partial marks? If you think about it, can anybody here justify partial marks except through some rubric? That's a term I learned recently. So you create all these partial mark schemes, but in the end you know it's all bogus. You just cooked up that scheme. There's nothing sacrosanct about it. It's just that the scheme is consistently applied. Student, keep quiet. Don't question the scheme. Okay, this is how everything works. Our 12th standard, 10th standard board exams work this way. Don't question it. In our case, we want to question it and say, is this a reasonable way of giving partial marks? So how do you check that? Given that no two humans can agree what is the correct partial mark, in most cases, right, you have a human generated gold data set and you see, is this giving the same result as a gold data set? Here I'm claiming there is no gold data set. There are just a lot of rusted iron data sets which each one has created, and you cannot use any one of them consistently. So what do we do? So essentially what we did is, we took pairs of incorrect queries. There's a correct query and a pair of incorrect queries. And we asked volunteers to classify the queries into 3 buckets, where one of them is clearly much better than the other, the two are, or the other way, and the third bucket is where the two are approximately similar. What is approximately sort of left it to the human judgment. So again, it's not perfect, but in most cases you can see which of these it should fit in. And this is reasonably consistent. With this definition, we say that, now how to compare? We say that if we generate partial marks for these 2 incorrect queries, if the difference in the marks is less than 10%, we say that they are comparable. Otherwise, one is clearly better. Again, this is a slightly ad hoc, but gives you some idea of did it work. So there is a table. Please read every single line, not. Let's focus on this line. So what this is here's a particular, these are the query pairs. And there are 2 correct queries. And the correct query size, we have a notion of size 18. And if you, these are query pairs. And so this does several things. This thing here, matches canonicalization, says how many pairs matched after canonicalization. So some of these may be the same. Okay, so then did they match? And the accuracy canonicalization says how many of the matching things were found to match using canonicalization. And you can see that 62% is not that good. So if you just canonicalize, you will reject a lot of correct queries which you shouldn't have rejected. And then if you do, so when I say accuracy of canonicalization, let me rephrase that. Here what we are doing is, we are not doing the edit path, we take the initial queries, we canonicalize, and give marks based on the edit distance between the canonicalized queries. So here, when we compare with that, 62% of the time, the buckets were different. Sorry, I misstated what this table is. I was confusing it with another one later in the talk. So here, what we are saying is, if we don't find the minimal path, we directly canonicalize the student query, instructor query, and find the distance. Then they are put in the wrong bucket, 38% of the time. Whereas if you do edit, essentially you get out of these 16, 15 of them matched in the buckets, and that's 94% accuracy. So edit-based things gives you better accuracy in terms of the bucket match. So that's an indicator, and if you see across the row, you'll see that the edit accuracy is pretty good. Now we ran this on our students, and I don't think more than 1 or 2 students complained, and that was because of some limitation of our implementation, not because of this thing. It was an unrelated problem. So students were happy with it. They didn't come and crib. And if you have ever dealt, I don't know if your students are like our students, but our students will come and fight over every half mark. Okay, nobody came and cribbed here. Okay, so now this one is the time for greedy versus exhaustive. Exhaustive is Dijkstra's algorithm. It's not the stupid algorithm. And you can see that it takes 31 seconds and so on in many cases. So that's a lot of time, whereas the greedy takes less than a second and works pretty well. The match, what we mean here is that greedy might miss a optimal minimal path. It may give a longer path. But we found that it was fine in all our cases. Okay. So this last part is, I said we check equivalence using canonicalization, right? So this is what I was confusing with earlier. So did canonicalization actually catch the equivalences properly? And if you see here, for various query sizes, these are different queries. There are 89 student queries, 2 instructor provided queries. Xdata said that 70 of these are correct, and 19 are out. The canonicalization said that 61 are correct. Okay, so canonicalization is missing some correct queries possibly, and Xdata might be reporting some wrong queries as correct. So the actual number lies somewhere in between. Initially we couldn't do this before we did canonicalization. Now we can check for these 9 queries which lay in between. It doesn't have to be exactly 9, but in this case I think it happened to be 9. For these queries where the 2 didn't match, we could manually check, and we found that there were 2 cases where Xdata was marking a wrong query as correct. So the canonicalization's accuracy was only 90%. So we cannot use canonicalization to directly evaluate. But we can use canonicalization to find minimal paths, and there we may give slightly less partial marks than we should have, but that's not a disaster. Okay, so that's it for Xdata. I'll show you some screenshots or a demo. Maybe, I don't know, how much time do I have? I think I have, yeah. I'll just, okay, let me, a couple of minutes. Let me just finish the talk and go to the demo for 1 or 2 minutes. So essentially, there's been a bunch of related work for introductory programming assignments. They actually have a much harder task than we do. They are not using SQL. They are using C or C# or whatever. But there has been some nice progress there. So initially, people looked at the mutations were supplied. We create a space. For programs, it's harder. So they had instructors provide a set of repairs. And later, they said for a MOOC, we have a lot of correct programs. So can we use those to repair incorrect programs and find the repair path, and then you can give partial marks implicitly once you know what are the repairs. So there's been a bunch of work recently. So this third one, SAFGen, was used in a Microsoft supported MOOC for grading queries, and they show pretty good results. So I haven't tried this, but this looks promising. So to conclude, we have been using it in IIT Bombay for quite a few years now, also at Harvard. It's available. If you want to try it out, you can download it, and it works well. A bunch of future work. We want to handle more SQL constructs, in particular multi-level nested queries. We want to do more canonicalizations. We want to cluster student queries so that we know what kind of errors are happening. Cluster wrong queries, not just the right queries. Provide better feedback and so on. So if I can take a minute to just give you a glimpse at the actual system. This is a Moodle we have set up for showing this. So what I want, why? Okay, so this is Moodle. I'm sure many of you have used Moodle. So from Moodle, we can have a direct link to the system, and this is a two-way link. So the marks which are computed actually come back to Moodle afterwards. So there are interconnection technologies. And here we have a particular assignment. Okay, so this, the setup was not, just 1 minute. Yeah, so this is, come on, move please. Okay, so here is a course, here's the assignment, and so I can view, this is the instructor view. I can edit questions, so this is the question, this is the English text. This is the answer that the instructor has created. And this particular one each has one answer, but you can have multiple answers. And then there's also a student view of this. Instead of spending time fooling around with that, I have some screenshots. I think I'll just use that to show you the remaining parts. So this was the instructor. The student interface sees the question. You can go and type in the answer with syntax highlighting and so on. And so this is the, when you answer a question. And in the graded mode, you submit your answer. It's tested on one sample data set so that minor syntax errors will be caught, and you're given a chance to fix that. But eventually, your submission is graded against the full set of data sets we have created. And in this case, the student's query was incorrect, and we have shown the data sets which prove that this query is incorrect. So that is the correctness part. This thing shows the partial marking. So essentially, it has laid out the two student and the instructor queries and highlighted parts which differed. And then it gave a particular partial mark based on this. And we allow instructor to override the partial mark in case our system messes up. We didn't have to use it much. And this is a kind of summary view. So you can see for a particular question, what are the answers and what marks people got. So you have an idea of the difficulty and who is doing it right. Okay, that's it for the talk. I hope we have time for a few questions. Incidentally, the name of the project X Data comes from not so old Hollywood. So you can, a data mining person would gather that all database people do is watch movies, either Bollywood or Hollywood.
So, questions? Yeah.
I want to check whether this tool can be used for code reviews for SQL industry.
Yes. So basically what you can do using this tool as is, be in the instructor mode, generate data sets, and this query might be the wrong query in this case. The programmer has written a query which might be wrong. We are generating data sets from the wrong query, potentially wrong query, have a tester see if the results are correct. And if the tester says, no, this result is wrong, then you realize that this query has some error in it. So absolutely, I mean, that was the original motivation for the project, to help industry.
So one more question, yeah.
Yeah, that's a good question. For duplicate tuples, we do have some of our rules will generate, our data sets will on purpose generate duplicates to catch errors where you should have had a distinct versus not have a distinct. So those mutations are specifically targeted.
Okay, well, let's thank the speaker again.
On behalf of the organization committee as well.
Okay, we have one more. Just give me a sec.
Our last speaker is Professor Shevde from Indian Institute of Science, and he's going to be talking about deep reinforcement learning for syntactic error repair. Professor Shevde.
Oh, is it?
What are you using? HDMI? Do you have a
it's-
VGA port?
No, it's their laptop.
For their laptop. You can try reducing the resolution.
Resolution, is it?
That might help. It's already low. Okay, now nothing is there. What's happening? Okay, it's pulled it out. Fine.
So, I thank the organizers for giving me an opportunity to talk about our work. So, this is a joint work with Rahul Gupta, who is a PhD student at IISc, who will graduate soon, and Professor Aditya Kanade. So, it's part of our AAAI 2019 submission. Yeah, so to give a background, see, over the last few years, there has been a lot of interest among the student community in learning programming. Okay, so as a result of that, many initiatives like edX or Coursera have become very popular, where they have started the MOOCs, massive open online courses, right? And where a student can register online, register for the course, programming course, and submit assignments and get them graded and so on and so forth. These initiatives have been very successful, but one of the problems is that the kind of feedback that a student gets in a classroom kind of environment, that it's not possible in Coursera kind of scenario because of the scale, right? So typically, many a times student gets frustrated when he writes a program, doesn't get compiled, right, or doesn't perform the things that it is expected to do. Most of us have, when we started learning programming, we had that frustrating experience when we write program. Of course, we expect that the program will compile in the first go and then run as expected, but that doesn't happen, right? So, so one of the motivations for this work was that, can we give a feedback to a student? Feedback in the sense, correct some of the errors that are there in the student programs, right? The reason why we use deep networks was basically that deep networks have shown a lot of promise in natural language processing. So we thought that we could apply some of those things in the programming language context as well, and we decided to use the reinforcement learning technique, which is different from the traditional supervised or unsupervised learning, where in supervised learning you have the labeled examples which one can use for training. In the unsupervised case, you don't have labels, right? But then you try to find some patterns in the data. So reinforcement learning is somewhat different from these two, where you don't have labels, but you get a reward for everything what is done. Okay. To give some example, yeah, so I hope you can see this code snippet. So this is a small C code. Let us not worry about what it does, right? So it has some compilation errors, right? So you can see that at line 4, right? So we use the GCC compiler to compile this program, right? So the compiler gives the error as a closing parenthesis expected at that place. Right? But ideally, all of us know that it should be really a comma instead of a closing parenthesis, right? And then compiler also throws another error at the same place, right? That something else is needed, right? Then again at line number 8, right? It shows a different. There should be a closing brace, but instead of that, it says that it is expecting expression, right? So these are the errors given by a compiler, right? And for a novice programmer, right, if he sees these errors, right, he doesn't know what to do. Okay. Now, from C, if you go to other language, right, then the student has to again learn the syntax and then try to do lots of things, right? So dependence on compiler always is not good, right, as far as the error messages are concerned, right? So we thought that we could use a reinforcement learning kind of algorithm to solve this problem. So let me. Yeah, so this is the motivation for our work, that the syntax of the programming languages is many times hard, and which makes the beginners struggle when they start writing new programs. And then when you go to a new language, you have to again learn the new syntax and so on, right? So it is essential to give some real-time feedback for the novice programmers, which is not possible in the case of MOOCs, right? Because of the large scale, right? And important thing is that the compiler error messages are many times misleading, right? You cannot use them to fix the bugs. Okay, so our objective in this work is to develop a syntactic error repair technique which can help the programmers to correct the errors automatically. Okay, and the solution strategy that we use is basically it makes use of reinforcement learning, right? So I'll briefly talk about reinforcement learning in this talk, but to give you some idea that in reinforcement learning you have an initial state and then the final state, right? And from the initial state you take lots of actions to reach the final state. So the initial state is basically an incorrect program, and then you have some actions defined on your based on the current state, And you keep doing those actions, keep taking those actions till the goal state is arrived, right? So in this particular work, we use two types of actions. One is the navigation action. So you start from the beginning of the program and then start navigating, like mimic a programmer's actions, right? So you go either to the right or go down, right? So that was the navigation action. And then we introduced some edit actions, right? So some edit actions could be inserting some token, inserting a comma, or inserting a semicolon, right? That could be a edit action, or deleting something which is probably unnecessary. And then the other thing is the replacement, right? So replace a semicolon by comma, right? Which was the error which was in the program that we saw earlier, right? So this insert, delete, and modify, right? These are some of the actions that we used. Of course, these are limited because we wanted to test our prototype, and that's why we could not. We didn't want to have a large number of actions, but those can be extended. So here is a small attempt to make use of reinforcement learning technique to fix syntactic errors in the program. Okay, so a lot of work is being done in this area, both from the machine learning community as well as the programming language community. And this you can see from the different venues of the conferences where the related papers appear, like ICML, AAAI are the flagship conferences in machine learning. Then ACM, SIGPLAN, ICSI, POPL, these are the from the programming languages side. And these are just the representative publications. In fact, if one searches Google, one would get lots of papers related to the automatic program repair. Okay, so one of the early works in this area was by Chris Pitch and some of his colleagues, where they try to learn program embeddings. So they wanted to represent a program using a real vector. Okay, so all this work was motivated by the use of word-to-vec, which was proposed by Mikolo and his colleagues in the document classification scenario. Right, so Mikolo and his colleagues at Google, they developed a technique called word-to-vec, right, where you represent a word by a vector. Okay, and the good thing about that word-to-vec technique is that the semantic relationship between the words can be easily obtained using the vector representations of the words. Okay, so that was the motivation for Peach's work, where they wanted to represent a program by a vector. So they collected lots of programs which didn't have syntax error, so they could generate a AST for each of those programs, and then for the AST, for every input and the output, they get a vector representations of the conditions at the input and the output level, and then try to map the input and the output using some matrix or some transformation. Okay, so that's how they try to represent a program using a vector. And then if you want to know whether the two programs are doing the same thing or not, what you could do is that you can compare the two vectors, and if the two vectors are close to each other, that means that the programs are doing something similar. Okay, so that was their idea, and this work appeared way back in 2015. Then SKP was one of the techniques that Poo and his collaborators proposed. So they again took collected a set of correct programs and used them to get a distribution of the programs, possible correct programs for a given incorrect program. Okay, so they always made use of the some of the correct programs which have been submitted to say any of the MOOC courses. So a couple of years back, we came up with a technique called deepfix. Okay, so which is again a technique which was developed in the supervised learning context, where we had the input program, which could be a buggy program, and then the output could be the fix. Okay, so we posed it as a sequence-to-sequence learning problem where the program can be thought of as a sequence. The output is fixed, means a particular line which is buggy, which is given, which is corrected and given as the output. So output again is a program statement which is again a sequence. So we posed it as a sequence-to-sequence learning problem and used a bidirectional recurrent neural networks to solve this problem. In last year's ICSI, Sahil Bhatia and others came up with a technique called synfix. So again, this technique also uses, it makes use of a lot of correct programs to develop, to find out bugs in incorrect programs. So this year's POPL, there was a paper by Alan and others, which is, they call it as a code to vec. So basically they take a program and try to convert it to a vector. Okay. So this is a much sophisticated version of what Peach and others did in their ICML 2015 paper. Right. So again, they also require a AST. So that means that the program should be compilable. So all these techniques typically require some correct codes, right? And they make use of those correct codes to fix the bugs in the other programs. What we decided to use was that we thought that many times these correct codes may not be available, right? So, can we come up with a technique which, without using any correct code, right? We'll try to learn based on only on the compiler error messages. Number of compiler errors. We do not look at the compiler error messages, but only look at the number of compiler errors. Okay, first time we used the reinforcement learning idea to fix a program. The training is done through self-exploration, so without any supervision. So this is not does not use any supervised learning ideas. And we found that it outperforms some of the state-of-the-art techniques like diffix on a corpus of C programs which had typically some typographic errors. So these are the student programs, the CS 101 course where the students submit some assignments and then wanted to see how this technique works on those C programs. And if we use some expert demonstrations, then we achieved some 5 times speed up on training. So I'll give some more details now. By the way, this code is available. Rahul Gupta has created this, has developed this code and has made it available on this site. So those of you who want to use it can easily use it. Okay, so let me just briefly talk about reinforcement learning. Yeah, so this is a scenario where you don't have any labels available. So on the right side, you'll see a grid where that right corner is the starting point and you have a goal point, right? So in this grid, one wants to move from the starting point to the grid, the goal point. So the black boxes are basically the obstacles. So you can think of it as a mobile robot moving in some environment in a room, right? Where there are some obstacles. So obviously the robot, when it starts moving, it may go and hit some of the obstacles, right? So that's how the robot will try to learn the environment. Okay. So these are the directions, the 4 directions in which a robot can move from a given point. You can also think of it as a child moving in a park, right? And then there are some obstacles here and there, and then the child tries to learn, right? By it will hit the obstacle and then again make a decision as to move to some other place. I mean some other next point and so on, right? So so this is one of the problems that one comes across in reinforcement learning. So it's basically a trial and error kind of technique that you make a mistake, then try to correct it, and keep doing this, and try to learn the environment, right? So the aim here is to maximize some kind of reward. So I'll talk about that reward sometime soon. And the challenge is the exploration versus the exploitation, right? So it's always a problem whether if a mobile robot is moving in some environment, right? Whether should it explore some new area, or should it just use the existing knowledge and exploit it as much as possible, right? So there should be a balance or trade-off between the two, right? Sometimes you want to explore, sometimes you want to exploit. So every time you don't want to go to the same restaurant which you have been going to, right? You may want to explore some of the new restaurants which have come up in the city, right? So there should be some balance between the two, right? And this is what typically one tries to do, right? So in a sense, you can think of it as an agent who wants to learn the environment, right? So the agent gets the current state of the environment. So the state ST is made known to the agent, right? And based on that, the agent takes the action, right? Whatever is the action, right? And then due to that action, the environment, there might be a change in the environment, right? So environment goes to a new state, right? And then the agent sees that state again, and so on. Also, as part of that action, the environment also gives some reward to the agent, right? And that reward is basically the R, the reward R. Okay, so if you think of a child moving in a park, right? Then with his mother, right? So if the child goes in the right direction, the mother appreciates it. If the child falls or makes a wrong move, right? Then the mother scolds him, right? So so this is basically a reward. Could be a penalty, right? So so this process can go on, right? So a typical episode could start with some initial state S0, right? And then there is a reward which the agent has used, which is R0, and then it goes on for say T steps, right? So with the starting state as S0, the total reward of that episode could be R0 plus R1 plus up to RT, right? Sometimes people use discounted reward where you give less importance to the rewards received later in time, while more importance to the rewards which are received currently, right? So many times people use those discounted rewards, right? So the idea is that how do we maximize the total reward? How does the agent maximize the total reward, right? Because the more the reward is, right, the better is the learning of the environment, right? So here is a sample grid, 3x3 simple 3x3 grid where there are 7 states, and then there are 2 goal states, right? So the goal states, once the agent reaches one of the goal states, the agent gets a reward of either +1 or -1 depending upon which goal state did the agent get into. And of course the actions are the usual up, down, left and right, right? That are the typical actions that one can have, right? So here is a simple case. So so the actions that the agent takes at every state, right, that is called the policy, right? So here is a sample policy that I have shown here, right? So if you are at the northwest corner, right, the policy could be to move right, right, and then and so on, right? So the different directions in which an agent can move, they are shown here. This is just a sample policy. One could have a different policy here, right? So if suppose you start from a northwest corner and want to reach the goal state where you get a reward of +1, right? So one could move right, and then down, and then you hit that, you reach the goal state, right? So that's the simple thing. So this is called the deterministic policy, that you start from a state and you know how to go, right? But in that process you don't explore new things, you don't learn the environment, right? So many times people prefer to use stochastic policies, right? So stochastic policy is a policy where even if I say that move right, right, there is still some chance that it will move in the other direction, right? So typical transition model could be something like this, where if in the intended direction you have a probability of you go in the intended direction with the probability P1, and in the perpendicular directions with probability P2 and P3. The sum of P1 and P2 and P3 will be 1 at every time. So typically, the P1 could be say 0.8 and P2 and P3 could be 0.1, right? So that means that so if you start from here, right, and then you want to move right, so then there is suppose the P1 is 0.8, right? So with 0.8 probability you move to this position, and with 0.1 probability you may move to this position, and 0.1 probability you may move up, but then you may hit the wall and then decide to stay back in this. Okay, right? So suppose this is the policy that we have chosen, right? Now the question is that how good is this policy? Okay, because finally our aim is to maximize the reward, right? So the policy, the given policy will give us some reward, right? So how good is the policy, right? So one can set up some equations to find out the final reward, right? And those equations are called Bellman equations. And for example, for this kind of policy, one could come up with the final rewards, right? So that means that if I start with this state, right, I would get a reward of 0.555, right? On the other hand, if I am close to this goal state, you will see that the reward is more. Okay, so the more close you go to the final state, the more the reward you get. Okay, so if you see this, right, this state, right, so here the action as per the given policy pi is to go up, right? But then if you see here, the reward associated with this state is 0.50, but then the reward associated with this state is 0.58. So I am better off going to this state from this state rather than using this, right? So this is the advantage that I have if I choose a different action instead of the current policy. Okay, so this is the advantage function that one can use to maximize the reward. So there exists different methods called policy-based methods like reinforce, right, which try to optimize the policy. There exist different methods called value-based methods, which fall under the category of Q-learning, right? So in our work, we use a variant of actor-critic method. So actor-critic methods are basically you have an actor and a critic, where actor selects actions, right, and based on the policy, and the critic basically decides whether the policy is good. So the actor tries to take some actions which could be which could maximize the reward, and then the critic basically finds out how good is the action, right? So again, you think of it as a two-player game where actor tries to play the game of deciding the policy, and then the critic tries to find out what is the advantage that one gets by using that policy, right? So it's a two-player game. One good thing about these methods is that they can be parameterized. Okay, so for example, if you have a current state, right, I can use a parameter. I can use a neural network to decide what is going to be the action, right? And similarly, if I have current state, I can also use a neural network to determine what is the value, right? So the parameterization can be done, and that makes the things more easy because once you have a parametric approaches, parametric models, you can easily set up an optimization problem, right? And to design a policy which will give you maximum reward. So you can set it up as a optimization problem. right? And different variants of this exist, like advantage actor critic method, where you actually take an advantage function, right, and parameterize it. Or there is another variant which we used, which is asynchronous advantage actor critic method, which turns out to be faster. Okay, so let me come to the actual framework that we used, right? So so we have a program, right? The program string along with the cursor position is a given state. Okay, so it could be, you could just start with the beginning of the program, so that could be your initial state. Then you take an action. As I said that we have two types of actions. One is the edit action and the other one is the navigation action. So edit action just changes the cursor position, right? Sorry, the navigation action just changes the cursor position. So you either move right or move down. Okay. The edit action will make some changes in the program, right? It could be, insertion of a token or deletion of a token, right? So you have these two kinds of actions. So once you take the edit actions, right, then the program string has changed, right? And we want to see whether the given edit is good, right? So we give it to a compiler, right? So if the number of compiler errors reduces by 1, right, because we have made one edit. So if the number of compiler errors reduces by 1, right, there is a reward, partial reward. Okay, and once you go to a new state, right, then one can go through it again and again, right? So if the number of compiler errors becomes 0, right, then that's a full reward case. That means that we have reached the final state, right? Otherwise, one has to repeat this. Okay, so this is one part of the framework, and the other part. Okay, so so as I said that there could be a partial reward if the number of compiler errors reduces by 1, and if the number of compiler errors becomes 0, that's a goal state is achieved, right? Otherwise, one goes back to the new state because there has been a change in the cursor either in the cursor position or in the program string because of the edit action. Then one goes back, right? And then this process is repeated. Right? So the maximum reward is given when the program when the number of compiler errors is 0. So remember that we just look at the number of compiler errors, right, to decide the reward. We don't look at the actual error messages because actual compiler error messages because they are sometimes misleading, right? So we just use the number of compiler errors as the indicator of as an indicator for the reward, right? Right. And now this the program string and the cursor position, they are given to the encoder. So I'll talk more about this, right? So the program can be thought of as a sequence of tokens, right? So these x1, x2 up to xn, they are the tokens in the program. They are passed through the LSTM network, right? And the LSTM networks will give you some output, and these are averaged, right? And this is the representation of a program, the real vector representation of a program, right? And once you have the real vector presentation, then you can do any kinds of manipulations with that. So they can be given to a neural network to decide the value of the given state, because the input is a program state, right? So the value of the given state, so this is the parameter that I am talking about, the linear network, and you could have a linear network followed by a softmax to decide the policy. So the pi is the policy which decides the action based on the given state, right? So these parameters of these networks can be learned by setting up a appropriate optimization problem to minimize the loss. So the loss basically is decided based on how much is the reward which is attained. Okay, so this is a simple model that we use. So let me see. So I have a video, but I'm not sure whether it is. Yeah, so sorry, there was some video which I wanted to show, but somehow it is not showing up here. Okay, but anyway, so this is how our trained agent, reinforcement learning agent work. So this is the same program which I showed earlier, right? A trained agent, right? This is a new program given to it. So it will do these navigation actions, go to the next lines, and at this fourth line, it will start moving right, and it will go to a point where actually there is an error, right? And it will replace it by a comma, right? And then go to the next line and keep going down till you come here and then put a closing brace here, right? So this is these are the actions which are done by our trained reinforcement learning agent on that sample code which I show. Unfortunately, this video is not working. Otherwise, I would have shown that. Okay. Yeah. So we use some students' programs which were submitted as part of introductory programming assignment. So we tried on 93 different programming problems. We used program because of the memory limitation. We could take programs which were up to 450 tokens, right? And use cross validation for evaluation purposes, right? So this is the training performance of our tool, right? So on the horizontal axis, you will see the number of episodes that our tool has seen, right? And you can see that the number of fixes increases as the number of episodes increases, right? You require quite a large number of episodes to achieve a reasonably good training set performance, right? And the reward also, you can see that the rewards also is getting maximized. The number of edits as the iterations progress, they also start coming down, right? And then this is the plot of the episode length. So we also tried one more thing where for some programs we use the actual fixes provided by the instructor, right? So this is what we call it as a training with expert demonstration. Yeah, and then this is the, I'll just take 2 minutes. Yeah. So this is the performance that you see here, that with about, instead of 5 million episodes, with about 1.5 million episodes, with the expert demonstrations, we could achieve similar or better performance. Yeah, in terms of numbers, you can see that there were about 7,000 erroneous programs, out of which the earlier tool DeepFix could fix only 1625 programs completely, while there has been some improvement using RL Assist and RL Assist plus demo. But one should remember that DeepFix was a supervised learning technique which made use of the labels available, while RL Assist didn't have any information about the labels. Yeah, and just to see whether the things were happening correctly, so we took some of the test programs which were buggy, and these are the program representations for different lines before the bug is fixed and after the bug is fixed, right? So we can clearly see that we could capture, we could correct those bugs without any issue. Yeah, so this technique, we basically use it for syntactic error repair, and it outperforms some of the state-of-the-art techniques. And we also found that using expert demonstrations, we could train the things in a much faster way, right? So one of the things which I forgot to mention is that the training required about 3 weeks on a GPU-based machine, right? And we want to speed up in future by using some second-order optimization techniques. And of course, initially the number of errors that we handled was pretty low. We want to handle more classes of errors and try to extend these techniques to large code. And one of the important things nowadays is explainable AI, right? The actions taken by the agent, can they be explained, right? This is something that we have been looking at. So,
sorry,
yeah.
There is apparently a bus. So
Yeah.
Sorry for
Yeah. No, I also have to go by that bus.
So I guess you can have one question. Yeah.
Syntactic error repair can change semantics also. So how will that be?
Yeah, so that is currently not done because the current setup, we just try to reduce the number of compiler errors, right? But in that process, what happens to the program, that is, yeah, we haven't looked at that, but we certainly would like to look at it.
One question on this.
Get one.
Similar techniques we use in medical imaging. Okay, but instead of correcting things, we highlight gradients for final interpretation. So like that here now, maybe simple things when you correct, but then the complicated things, maybe like programmer.
Yes, that can be done. That can be done.
And then consider warnings also in similar lines.
Oh, warnings we didn't. No, we just looked at the number of errors by the compiler. We didn't look at even the compiler messages, error messages, right? So we didn't look at any other messages other than just the compiler, number of compiler errors.
Yeah, on behalf of the organization committee. Yeah. Okay, so all good things come to an end. So let's have a quick concluding session because in another 10 minutes time, the bus is leaving for the airport and I'm told that there are 15 of you who will be traveling by the bus. First of all, let me thank the organizers, I mean the ACM, for having given us the opportunity to have this Compute 2019 here in Goa. And one person behind the scene I think we need to appreciate is the COO, the Chief Operating Officer of ACM India, Shekhar Sahasrabuddhe. Sir, this is the memento that we thought we need to present. Many of you may not be knowing that he was the person behind the scene who was making all the arrangements. Thank you, Shekhar. Also, we would like to thank our sponsors, the Google, Persistent, TCS, and ICETRIS. Of course, program committee has put in an excellent program. Thanks to Venkatesh Raman, who was sitting on our head to make sure that we have been calling people, sending emails, and of course, Abhiram, Madhavan, and all others from the council who have been supporting us. I think if I will fail in my duty, if I don't acknowledge my colleagues in the department, as well as the support that I got from Vandana and the whole team of my students. So let's give them a big round of applause. Please stand up. I would like to, our students, please stand up, right? I mean, let's see right, some of you, right? So thanks, and we look forward for your support for the next conference that we have, Technology for Education, in December. So please keep your spirits high so that we can have another successful organization here in December.
Okay, and I think we should have a round of applause for Professor Kamath as well. Thank you, sir.
So there is a tea waiting for you, and then you're on your own.